Okay, hello everybody. Good morning. Welcome to our session 2 on Get Certified for the Data Engineering on Google Cloud program. We will start in about 8 minutes. It's like 5 minutes after the hour. We are using India time here, 9 in the morning. We're going to be working until 1, 4 hour half-day session today as we did yesterday. Okay, so sit back, relax. If you're gonna go get a drink, coffee, tea, water, go for it. We still have time. We will be starting our second session in a few minutes. Okay, so I will be, of course, as we kick this off in a few minutes, sharing all the information that we shared yesterday about the program, the material, and the session, the labs, and everything. Okay, so again, sit back, relax, and we will be starting in a few minutes. Thank you. Okay, hello again. Welcome everybody. This is the Get Certified program for the professional data engineering certification on Google Cloud. This is session 2. We kicked off the program yesterday and we will be wrapping up this first session today. Okay, so let's take 5 minutes, people. Let's take 5 minutes. I see people connecting as we speak. We are missing a few compared with the um, audience that we had yesterday, but we're going to start shortly. Okay, so what I'm going to do now is to set up here a timer, 5 minutes, and after that, we will be kicking off the session. Okay, and of course, I will be sharing all the information again about the program at the beginning and during the session this morning also. Okay. Okay, let's go ahead and get started. Hello, everybody. Welcome. Good morning. This is the Get Certified program for the professional data engineering certification on Google Cloud. We are completing the first course we started yesterday, and we will be wrapping up today. In case you missed yesterday's session, let me quickly introduce myself. My name is Guillermo Perazzo, and I am the trainer for these two half-day sessions. Okay, I will be completing the course on Introduction to Data Engineering on Google Cloud. So let's go ahead and review the program, the requirements. We did that yesterday, of course. I will be sharing this information now during this introduction, and throughout the session, we should be working for 4 hours, people. We should be finishing at 1 o'clock India time. We are using India time as a reference here. And like yesterday, we're going to be running the session between 9 and 1. And in the middle, we will be taking a short 15-minute break, okay? So let me go ahead and review the program. Name here. So the program started yesterday, June the 16th. We are finishing up today. It's 4 hours long. This session here in this YouTube channel will remain available for a week, okay? If you are missing, you missed yesterday's session, or you are not, if you are here online, probably you will be here with me today. But if you miss this session, or you need to drop or anything, you can watch this presentation for 7 days, okay? Google keeps these 2 sessions in YouTube, yesterday's and today's, for 7 days. So you can rewatch it, use the link that you received, that the one that you use for connecting here, and you should be able to watch this presentation. Will be online for 7 days, okay? Check your emails, okay? Google will be sharing information about the program via email. Please double check that those messages, those notifications from Google regarding the program don't go to your spam folder. So double check. For instance, must be some action required, create Google Skills account. This is an email that will detail how to access the Google Skills platform, which is very important, because in order for you to qualify for stage 2 of the program, you need to complete activities. And in order to do that, you're going to need access to the Google Skills platform, okay? So what do you need to do? This program is divided in 2 stages, okay? Yesterday, we started stage 1, which is this session that will run for a week, starting today. And I'm presenting here this Introduction to Data Engineering on Google Cloud, and I will be demoing. I started yesterday with the first 3 labs, and I will complete the course today demoing the rest of the labs, 3-4 labs that we have for today's session, okay? Then you will have 1 week, this week, to complete at least 5 out of the 7 labs. And the labs are here. Let me share with you. Of course, you have access to the link to the classroom. The first 3 labs are enabled already, because those are the 3 labs that I ran for you yesterday. And today, I will be demoing the other 3. Let's see if I can demo all of them. I'm going to try to demo at least 3 of these labs, see if time permits, and then I will enable them all, okay? Yes, the labs, the rest of the 4 labs that you see here are still disabled and will remain disabled for the session, okay? I will enable them by the time we wrap up at noon, between 12 and 1 India time, okay? So yes, if you see these labs disabled, they are disabled and will remain disabled. Let me make this a bit larger for you so you can see it here. Okay, the labs will be available until June the 22nd, people. You see that information here. You don't need to ask about that. You can find the information regarding the deadline for stage 1. You have June the 22nd until 11 p.m. India time to complete at least 5 out of these 7 labs, okay? Which 5 out of these 7? Any. You need to complete any 5 of these labs, okay? So again, the labs will remain disabled. The rest of the labs, the 4 labs that we have for today, will remain disabled until the end of the session, okay? And again, June the 22nd, next Monday, is the deadline for you to complete these at least 5 labs. Of course, if you have time, please go ahead and check them all, do all of them. They're useful in preparation for the exam. But you, according to the requirement for the program, you need to complete 5 out of these 7, okay? The opening week with your classroom environment. This is the classroom environment, is what I'm showing you here, right? And you receive, again, check your inboxes, check your emails. You should receive all the information from Google via email, how to log in, if you don't have an account, how to create it, and all of that, okay? By June the 24th, 2 days after this finish of stage 1, you will receive again an email from Google, share your qualification result. Google will let you know if you qualify during this week for stage 2, and they will share information about the second stage of the program. The second stage, by the way, will run for a few weeks, like 6-8 weeks, and you will receive the information about stage 2, and hopefully by the end of that you should receive a voucher and register for the exam, and within a few weeks again you will be a new certified Google Cloud data engineer, okay? So you have some information here as well. There are some links. Look at the chat in this YouTube channel, people, on the chat panel. At the bottom is being pinned a link to a chat bot. It's a bot, what is it called? It's a bot that you can use to ask for help. It's a virtual assistant. It's a virtual assistant. You will find the link there that you can use to ask for any kind of support. And then you, again, check those emails. You contain links to, there are some online forms that Google prepared that you can fill out and ask for help, for support, any questions, any comments that you may have regarding the program, okay? The labs are disabled, okay? The labs are disabled. I just explained that. Will remain disabled for the rest of the session. By noon India time, I will enable them all. If you are online by then, you will see me actually enabling all of these labs. Today, I will be demoing them, and then you have until June the 22nd, next Monday, to complete. Again, remember, 5, at least 5 out of these 7, okay? Okay, I think that's all I have to say. I will be, as I told you yesterday at the beginning, people, please, I'm sorry, I apologize. I will be repeating this information a lot during this morning because I need to make sure I see people connecting as we speak. So some of you may be missing this, so I'm gonna be sharing this a few more times during the day. Bear with me, I apologize for being so repetitive, but we need to make sure that we convey this information properly to everybody joining the program, okay? So, let's review the agenda. So I already introduced myself here. So let me go, where is the, oh, okay. So hold on, just give me 1 second. Let me show you the agenda for the program. Remember that this is actually a full day program that we are divided in 2 half days, okay? We did the first half yesterday, and the second half, of course, we will be doing it now. Where is it here? Today we will complete the session talking about these topics, okay? So yesterday we started introducing data engineering tasks and components. We talked about the role of a data engineer within the organization. Remember, the role is, in simple terms, we want to make sure that we move data around in order to make that data available for the business to run it and add value to the organization. The data should be available and properly configured. Remember that conversation about data lakes and data warehouses. We talk about lake houses as well. And that's essentially the role of a data engineer, okay? We talk about data replication and migration. Remember the products, right, that we cover. We talk about BigQuery, of course, cloud storage. We work with DataStream. We work with lake houses as well, right? What is used to be called Big Lake, it's no longer called Big Lake. Now it's called cross-cloud lake houses. and extract and load. And then we introduce these three patterns, remember, to build, because essentially the role of a data engineer is to work with data pipelines. Okay, what we are doing as data engineers is building and running data pipelines, that is moving data from the sources to the sinks where the business will be consuming the data or any kind of downstream applications, considering the transformation. So the pattern, again, is called the ETL, extract, transform, and load. And we described there are three ways to implement that. And yesterday we covered the first one, probably the simplest, extract and load. You see the item number 3 here. We extract data, we assume that the data is ready to be consumed downstream, and we push it. Now we're going to talk about transforming the data. What if you need to make some transformations on the data in order to make it available for consumption, right? So we have the extract, load, and transform. Extract the data, load the data. For loading the data, we're going to be using some kind of a staging area or landing zone, and then do the transformations on the data. Remember that conversation regarding the fact that transformations are associated with data quality checks, aggregations, checking for privacy, checking for safety, checking for security. If you're dealing with sensitive data, what we call PII, personally identifiable information. Please, people, pay attention to all of this aspect, right? Sensitive data protection, data loss prevention, PII, personally identifiable information. Remember, as I told you yesterday, when you hear me today telling you that something is important or something is relevant, what I mean within the context of this session today and yesterday is that you will find questions in the exam. The certification exam is like 50 multiple choice questions, and some of the questions will be about this topic. When I say this is important, people, is because I'm just telling you that you will find more than one probably questions in the exam testing you on that particular topic, right? And this is critical. What I just mentioned, dealing with sensitive data, you will find a few questions for sure in the exam on that, right? And then the extract, transform, and load. This is another way to implement this transformation. Again, this is all based on the complexity of those transformations. One of the things that you need to do as a data engineer is to assess the level of complexity of those transformations, and then based on that analysis, pick up the proper tools on Google Cloud to implement the data pipeline and to run and operate. Remember that another very important thing is the development phase, when we as data engineers are designing, building, and deploying these data engineering processes, these data pipelines. And the other important thing is the operations, the maintenance, right? Making sure that over time, whatever we build and run remains relevant over time, right? And we're going to finish up talking about some automation techniques. It's very important. We mentioned that yesterday. You need to understand what is the proper level of automation. Yes, it must be something that we can qualify as proper level of automation, the right level of automation, going for something that may be on one side of the spectrum completely manual, 100% manual, to the other side of the spectrum that something could be fully automated with no human intervention, which in some cases could be usable and something that we are aiming at. In some other cases, no, due to the sensitivity or the level of alignment with some kind of compliance or policies or regulations, it may require some checks that needs to be just checkpoints and need to be manually implemented. Okay, again, in this final module today, this morning, we're going to discuss some automation techniques and some tools. Remember that we mentioned yesterday these sessions, and in general, when you're working as a data engineer on Google Cloud, another important thing is, of course, this is a Google Cloud session. This is a Google Cloud certification, so naturally most of the products are Google Cloud. But keep in mind, and this is super important for the exam as well, people, that Google will test your knowledge not only on Google Cloud, so because it's quite common that organizations these days use what is called multi-cloud or hybrid architecture, deploying services that run across multiple cloud providers and also on premises. You need to be familiar with that, right? This is not about, yes, it is a Google Cloud certification exam, but that doesn't mean that the only products that you need to be familiar with to get certified are Google Cloud products. You need to be familiar with other services that are usually open source, right? We talked about the Spark, for instance, yesterday, and we're going to revisit the Spark. We're going to be talking about the Spark. Spark is a prime example of what I'm telling you here, right? Which is not the Google Cloud product. However, you're going to need to have certain level of familiarity with Spark. I would say the same with, I don't know, Terraform, for instance. That is, again, another example of a non-Google related product, but very relevant for building, especially provisioning infrastructure to run these data workflows, okay? So I'm gonna keep this agenda here, and let's go ahead and kick this off. Remember that I will be demoing the labs here, so I'm gonna start. Our first module here is on, let me see. And remember that the labs that we have for today will remain disabled, okay? Will remain disabled during this morning. I only enable the labs at the very end of the session. So if you still see, and let me show you one more time, why not? If you see that the labs are show disabled on your side, that's fine, that's fine. I will enable them at the end of the session. Remember the lecture note, people. I forgot to mention the lecture note. If you go here to the classroom in Google Skills, you have two tabs. Actually, one tab is the labs and the other tab is the lecture note. And these are already available for you people. If you want to follow along my presentation, just look, we are starting, by the way, today with module 4. But you can use this. This is a PDF. Each item here in this list, module 1 to module 7, is a PDF file that contains the slides that we are presenting here. You have access to that. Go ahead and check this out. And this will remain this. Keep in mind that this deadline here that you see on the right-hand side, June the 22nd, is to complete the labs. This June the 22nd is your deadline to complete, remember, at least 5 out of the 7 labs. This content here, the lecture notes with the PDF file for all the modules with the decks, the slide decks that we are using here, that will remain there available for you to access and use as a reference material to prepare for the exam, okay? So again, important to check those lecture notes as well for the content that we are covering here. So let's go ahead and talk about the extract, load, and transform data pipelines, okay? So extract, load, and this is the ELT, right? Remember that we are presenting this extract, transform, and load, and we covered yesterday, we finished the session talking about extracting and loading, no transformation required, the data transfer service, remember all of those products. Now we're gonna talk about loading the data and then doing transformations. And in the next module, we're gonna talk about extracting, transforming the data, and then doing the transformations, right? So we're going to talk about Dataform. The main product that we are introducing here is called Dataform, which is part of Google Cloud. And today, as I did yesterday, I will be demoing some of these features here. I have my demo environment here in Google Cloud. This is my Google Cloud demo environment from Jellyfish. And just to show you what we are doing here, we're going to be working with Dataform today, right? And of course, as you run the labs, you notice how prevalent BigQuery is, right? How you run queries, load data. Normally, the data, the BigQuery is the platform for the enterprise data warehouse, and naturally extremely relevant as part of the responsibilities of a data engineer. Secure that we are properly feeding those data warehouses, right? And today we're going to talk about another option to build build your data warehouse, which is Bigtable. That we're going to be overviewing. Remember that this session, people, is called Introduction to Data Engineering on Google Cloud. So naturally, I can tell you, and you will see this very clearly if you qualify for a stage 2 and you enroll to a stage 2 and start covering all of this content in detail. You will see, people, that basically any product that we are covering here, we have a few slides to overview and to describe the product. Again, on stage 2 of this program, you're going to go very deep, right? You're going to spend several hours actually working on each one of these products that we are presenting here. Again, take this as an overview. The goal here is for me to introduce you to all of these products and services, knowing that when you qualify for a stage 2, you're going to start going deep. That's why we have like 6 to 8 weeks scheduled for a stage 2, right? You will see that you're going to need to go much deeper into understanding the capabilities and the ways to use these services. It's critical, again, as a role of a data engineer, to make sure that you properly map your business requirements, your constraints. You're going to remember that another very important thing that is critical for the exam, in preparation for the exam, is everything that is associated with cost, right? Budget control, cost optimization. Yes, you will have a few questions in the exam where the question quite explicitly will ask you to, it's going to describe a situation. I'm going to ask you to find the solution, and the question will tell you explicitly, again, find the solution that is most, cost effective, or the one that would allow me to optimize the cost, or may describe that you have some budget issues and you need to adjust the cost of running. You will have, again, not one, but maybe a few questions testing your capacity to understand how Google charges, what is the pricing models associated with some of the products. This is something that you will learn. Again, I will be commenting on that here, and you will have to learn more in detail as you progress on stage 2 in this program, okay? Okay. So data form, I just mentioned data form. Let's go ahead and remember that I will be demoing the lab at the end of this module, okay? Once the data is loaded into BigQuery, there are multiple ways to transform it. So what we are doing here, this approach that is called ELT, is ingesting data from the sources. That doesn't change. We covered that yesterday. All of those data transfer or migration processes that we discussed yesterday will remain. We are doing the same thing, but now instead of feeding the data into our downstream data warehouse, we are using this staging area, landing zone. We have some kind of data set in BigQuery to land the data. We know that the data is not ready to go. It needs to be, this is again what we call raw data, and needs to be transformed first, right? There are different ways to do that. We are landing the data in BigQuery. Of course, one of the key constraints, I wouldn't call it limitations, but it's clearly a constraint when you need to consider these transformations, is the capacity of being implemented, I mean, those transformations using SQL, because we are loading the data into BigQuery, and we discussed yesterday that BigQuery runs SQL. The language that we use in BigQuery to query our data is SQL. We will see here in data form that data form offers it's kind of advanced implementation of SQL. It's called SQL Extended, which is combining SQL code with JavaScript functionality as well, to enrich the capacity of these workflows, these processes, to manipulate your data transformation. But yes, there's clearly some constraints. In the exam, you see a question asking you to decide if you need to use ELT or ETL, the pattern for extracting data. One of the things that you need to look at the question for is if those transformations described in the question can be actually handled by the SQL language. Otherwise, you may need to consider other alternative, right? Which, by the way, we will discuss in the next module. So procedural language, scheduled queries, because again, you need to consider this is kind of going into the direction of automating the process, right? Running this on a regular basis. We discussed also yesterday the different scenarios here, whether it's time-based scheduling, something that needs to run regularly, and you can schedule it to run, I don't know, it doesn't matter how often, right? The frequency itself doesn't matter, whether it's, I don't know, once a day, once every 5 minutes, or once a week. As I said, it's not that relevant as long as you properly schedule that. Or maybe event-driven, and we're going to discuss later on what do we mean by event-driven, which is something that we discussed yesterday with data stream. Remember, one of the key capabilities of data stream, implementing this capture data changes, is that when there is a change in the database, that triggers a process that will update your data warehouse, right? Jupyter Notebooks, because you're going to need to manipulate code. We are going into coding here, people. We are moving more into the coding part. You will be manipulating code, whether it's SQL or Python or JavaScript. But now, when we get into this level of complexity on handling transformations, sophisticated transformations, we need to start considering manipulating some code, okay? And data form, as I said before, I will tell you about specific product within Google Cloud that would help you build pipelines using a specific workflow that will handle all of these different components. The complexity of ELT in this case, that you're going to need to use different components and coordinating and orchestrating them all is usually the challenge, right? Scripting and programming, as I just mentioned, this is a lot about programming, scheduling capabilities, and dependency management. Very important. Let me comment on dependency management because this is what Dataform basically aims at, right? Handling complex dependency. This dependency management is something that we're going to be discussing also in the final module today, talking about automation, right? You need to determine when you have a sequence of steps in order to implement the workflow, the data pipeline, what is the level of dependency? You need that to determine the sequence, how to program your steps, and also for performance optimization, because if you manage to somehow reduce or minimize or even eliminate the dependency, that means that I may be able to run certain processes, certain steps in parallel. So one of the key things about, in general, running these processes on the cloud, and in particular Google Cloud, is the capacity to distribute, to parallelize. We're going to talk about the Spark. We're going to talk about Dataflow here, which are very powerful tools capable of provisioning these clusters of workers, resources, which are nothing but virtual machines, servers, basically. And we can run things in parallel to, again, reduce the latency and increase the throughput, right? Processing this pipeline. So dependency management is one of the key part of the kind of analysis that the data engineer would need to perform in order when we are designing the architecture, the topology of our data pipeline, okay? ELT pipeline to apply transformation after data is a stage. That's the key term that I mentioned already a few times. A staging area, landing zone. There are different terms that we can use for that. But the idea is that you have structured data in cloud storage. Remember that part of the conversation we had yesterday, right? We are landing data from our external data sources into cloud storage. Cloud storage is our data lake. And then we stage the data into BigQuery, and then we do the transformations. In this blue box here, we will be discussing different ways using Dataform or using BigQuery. You can always do it manually running SQL scripts, right? As long as the transformations can be handled by SQL, you can implement it here. If you need something more advanced, we're going to discuss some features available in Dataform. And then, yes, pushing the data to BigQuery. When you see production table here, this is the actual data warehouse, right? SQL scripting and scheduling with BigQuery. So, of course, BigQuery supports procedural language queries to perform multiple statements. Again, this is a stored procedure, right? You can build, if you come from you have some kind of background on a classic conventional relational databases, you are familiar already with this kind of processes, stored procedures, multiple statements in a sequence, we share a state, management task. You can implement some complex logics like loops or conditional statements to handle, I don't know, forking or merging data. Commit, rollback, you can use transactional approach, kind of an ACID approach. So you have all of these things. But yes, you're going to have to write SQL code manually in a way, right? You can use user-defined functions. User-defined functions is another way to code, to script your transformations. User-defined functions, different from stored procedures, is that it supports JavaScript. However, people, the message here is be very careful, okay? Google itself shows some, I'm not going to say concerns, but some warnings, I will say, be careful with user-defined functions and JavaScript, mostly due to performance, because this is essentially BigQuery compiling somehow JavaScript code. We will require special libraries there. And then security, of course. The main concern with using JavaScript code is the fact that you can ingest, somebody maliciously can inject unauthorized code and do something that is not what we need to build here, right? But UDF, user-defined functions, can be used also to transform the data. We just mentioned stored procedures. collection of SQL statements, right? You have a very specific set of steps that you need to run in a given sequence. You can do that with these store procedures. You can run a Spark, Apache Spark on BigQuery. Remember that we mentioned that already. BigQuery is two services in one. Is a storage, managed storage service within BigQuery, and is the query engine or the analytics engine. This is an example of why Google does that and have two independent products running inside BigQuery, right? Because in this case, you can run Apache Spark code instead of using the query engine in BigQuery. We're using the Spark query engine, and we are accessing the data from BigQuery. This is very useful when you have data across different platforms, in Spark, on BigQuery, some other Hadoop like Presto, those kind of backends, and you can kind of standardize in a way the way that you run those transformations, regardless in which platform you are storing the data, right? But yes, you can run Spark code also in BigQuery. Remote functions, transformations with more complex programming logic. So here you see an example that you can run this remote functions using Python, for instance, right? These are the libraries that you can use in Python or other popular programming languages and call BigQuery data to perform this transformation, right? Specifying the connection, the endpoint, choose your Cloud Run function. This is usually implemented using services like Cloud Run, and we will see later on Cloud Run function. Our final module today, talking about automation, we will be covering these services, right? Cloud Run functions, Cloud Run, and other compute resources in Google Cloud to run these transformations on BigQuery data outside BigQuery, right? The idea is to doing this outside BigQuery. Of course, you can use Jupyter Notebooks for data exploration, very popular because it's very likely that data engineers or data analysts or business intelligence, whatever is basically working with these workflows, know how to use Jupyter Labs environment. Google provisions basically two products that support Jupyter Notebooks. One is called Colab Enterprise, which you may be familiar with the Collaboratories, which is an open platform available on the internet. You can use Colab without having an account on Google Cloud. Google brought that platform into Google Cloud. They call it Colab Enterprise. And then you have Workbench, which is another product on Google Cloud that you can use to run Jupyter Lab environments, okay? So there is a question in the chat, says, what is the primary factor to decide whether to use ELT or ETL? The primary factor, I would say, is whether the transformations that you need to do can be handled using SQL or these languages. This is the main factor that you need to consider. Later on, when we talk about ETL, extract, transform, and load, in the next module, I will tell you more about specific transformations or specific characteristics of certain transformations that may require another tool, like streaming, for instance, or doing some kind of transformations, computing a moving average or things like that. That doesn't mean that we cannot do it using this approach that we are discussing here, but we may have better tools to do that, and we're going to have that conversation after we introduce the next module, okay? So Jupyter Notebooks, again, you can use Jupyter Notebooks. If I go here, normally you're going to need to go to the Asian platform in Google Cloud, and you see Notebooks here. And here in Notebooks, you will see these two options I just mentioned, which are, just give it a second, here is loading, is Colab Enterprise or Workbench. You see the two options I just mentioned. Actually, Google acknowledged that using Colab Enterprise is very prevalent, actually, from users accessing data from BigQuery, that of course you can use the Asian platform here and deploy your notebooks and run code accessing BigQuery data. But in BigQuery itself, if you go to BigQuery, you go to the BigQuery Studio here. If you go to the BigQuery Studio and you open here a new query editor, there is an option here. If you click here, that you can open a notebook. You see here, notebook. This is kind of a new feature, It's been around for maybe a year or something like that. So you click here And you will see that in my query editor now in BigQuery, it will load a Jupyter Colab. It's actually using Colab here, and I can create my code here. I can create these cells with code. I'm running a Colab instance, Jupyter Lab instance here inside BigQuery, right? I don't need to go to the Asian platform. I can directly do it here. You need to add some text here. You can add some text. You can add some visualizations. You have all of these capabilities that are associated with using Jupyter Notebooks. Okay, Google added that now directly inside the query editor. In addition, of course, with the typical panels that you have that we've been using for our labs here, right? So this to show how prevalent, how Google acknowledges how relevant this part is, right? Let me see here. So I see a question in the chat here in YouTube said, do we expect questions on procedural language or scripting on certification exam? No. The exam is 50 multiple choice questions, and they are not going to ask you specific questions about coding. What is the function? What is the store procedure command that you need to do this or that in SQL? You are not going to have questions like that, because actually the role of a data engineer is not so much about that. Probably you have a team of developers within the organization actually doing the programming, coding those applications, but you as a data engineer will be responsible for manipulating that code, running it, provisioning the infrastructure. So no, in the exam, you don't see questions about specific functions that and how to code them or program them, okay? You don't need to learn the language basically for the exam. That is not what the exam questions are about. But of course, you need to understand all of these options that we just discussed, user-defined functions versus stored procedures versus remote functions and all of those things. And again, we're going to learn more about that. We are just overviewing them here. Of course, in stage 2, when you qualify and continue with the program, you will have more labs and more material, training material on these services, right? We talk about Jupyter Notebooks, save your queries and schedule them for repeating use cases. This is something, there are 2 things that we need to consider here in terms of scheduling. You can save your queries, you can schedule them to run on a regular basis. And again, this is something I can show you here, because if you look at the menu, you will find the schedule queries here. So here is how you create. Once you have a query, you create the query here, and then you will schedule it. And scheduling is time-based, okay? It's time-based. It's based on how often you need to run these queries. Of course, you will talk later on. There is a problem, okay? Not the problem. There is a kind of a limitation with this scheduling mechanism, which of course means that you're going to have to do it query by query, essentially, right? That could be a problem because, again, in complex environment, if you work for a large organization or a large team, you are not going to have a couple of data sets in BigQuery with 5, 10 tables and a couple of queries that you need to schedule and run regular, right? Now, companies deep into using and building these data warehouse environments using BigQuery and other tools, they may have tens of projects in Google Cloud with hundreds of data sets and maybe thousands of tables and queries and views and materialized views and all of that. So if you need to start scheduling one by one all of these queries to run, and then maintenance, remember that one of the key things that you need to learn for the exam to get certified is operations, how to optimize operational processes, just to make sure that those processes run properly over time, right? So you're going to be in the final module, we talk about these automation tools, and you will see like using Cloud Scheduler, using, I don't know, what used to be called Cloud Composer, that now is called Managed Spark. You have a Managed Airflow. We have other tools that would allow you to centralize and optimize the way that you manage complex environments when you need to schedule multiple queries. But yes, technically speaking, if you go to BigQuery, there is an option that you can book those and program those queries to run on a regular basis, right? And very important, again, when we're ingesting data, using these batch data pipelines, and these transformations need to be executed again on a schedule, right? On some kind of frequency. What if you need to perform additional operations after the query completion? This is very typical, right? After running your transformation, this query completion means implementing these transformations, doing things usually associated with quality checks, right? The typical downstream or subsequent SQL scripts are associated with data quality checks, checking on security measures, on security mechanisms. Those are the things. And here is when you start looking at this complexity associated with dependencies and coordinating and orchestrating multiple tasks that they need to be executed in a given sequence, right? That we're going into that direction of using a tool that would allow us to handle the complexity associated with orchestrating, synchronizing, and managing multiple transformations, right? Dependent operations. This is very important. Determine what needs to happen before in order to do something, okay? This is part of the conversation regarding understanding your workflow to the proper level of detail so you can plan the infrastructure accordingly, right? This is a key part of the responsibility of a data engineer. And here we acknowledge that doing this manually using stored procedures and user-defined functions or queries, and then running these queries on a schedule that you program in BigQuery. Again, we can do it. It's okay if you're building a proof of concept, you're testing something out, and you are doing probably a pilot. But for production workflows, this is different, right? Because again, you need to find a way to automate and implement the proper mechanisms to monitor and to operate these services, right? So we want to present a product in Google Cloud that could help with that, and it's called Dataform. It's a serverless framework to develop and operationalize ELT pipelines in SQL, right? It basically simplifies the development and management of these ELT pipelines using SQL. The idea of Dataform is, instead of remember these remote functions using Cloud Run and Python and Jupyter Notebooks, what Dataform offers is, listen, you're going to be doing everything in SQL. Yes, there are some extensions to SQL that are implemented in JavaScript. It's called SQL Extended, SQLX, but it's essentially SQL. You are going to be managing all of these, all the transformations, all of the tasks, synchronizing them, orchestrating them, checking for quality, checking for security, and all of that using exactly the same framework. That is the idea of Dataform. And of course, because it runs on top of BigQuery, like BigQuery is also serverless. Remember that serverless doesn't mean no servers. There are actually probably thousands of servers right behind the scenes. But it means that we don't get to configure, provision, run, administer those resources. Okay, it's all managed by the platform itself, which is super important when you're working with these external source systems that we cannot anticipate or we cannot control the amount of data, right? So scalability, the fact that we use serverless services is very important to secure that those workflows that we implement are handling scalability properly, right? Answering questions like, what happens if my traffic, for whatever reason, increases 1,000 times? I don't know, maybe it's not likely that that may happen, but it's still possible, right? Imagine these source systems coming from internet links, right? When you have data pipeline ingesting data from the internet, think of social media, right? Social media channel, which is something that if you're working with your marketing team, probably as a data engineer, you're gonna need to build this kind of pipelines, right? So the fact that you can provision and you don't have to worry about how much infrastructure is provisioned. However, as I said, you don't have to worry about provisioning that underlying infrastructure. However, you may need to, I'm not going to say you need to worry, but you need to pay attention to the cost, because even though those services are automatically managed, they are serverless, they are automatically handling the infrastructure. At the beginning of the month, next month, we receive the invoice from Google charging us. We have to pay. Google will bill us based on how much of those resources are automatically provisioned behind the scenes. That's why, as I mentioned before, it's very important that you as a data engineer are very well aware of that cost and the cost of making decisions about how to implement this technology, right? Data form unifies data. This is the idea. This is what I just mentioned. Unifies data transformation assertions. Assertion is associated with these quality checks, right? Implementing this mechanism that will check on certain quality requirements. And the automation, unifying. Again, we can do it manually. You don't need data form. This is the message that is important here, people. You don't need. Do we need data form? No. As we just discussed in the previous session, you can perfectly do this in BigQuery without using data form, using, again, store procedures, queries, views, and all of that, right? Scheduling and all of that. But with data form, we have one unified framework to handle all of this, defining tables, managing code, testing data quality, scheduling pipelines could be, and also automated using these tools, right? That's why we want. Again, this is part of the conversation, if you will, similar to the one that we're going to be having in the final module regarding automating workflows, right? So it's divided in two, very clearly is divided in two. You have a development part and you have the execution part, right? The development part happens in data form, again, which is this service embedded within the BigQuery ecosystem, right? SQL workflow development, use SQLX. You see here the first introduction to SQL Extended, which is, as I mentioned before, it's a SQL. It's the SQL language, the structured query language, with some libraries or components from JavaScript in order to enrich the environment with extra functionality, right? Of course, SQL is a language created originally to handle relational databases. So naturally, we need some extensions, some extra libraries to handle that, right? Let me see if there is something worth commenting here. Data form, create, compile SQL workflows using, and there is a compilation. There is a compilation, real-time compilation. We are compiling. This is classic for programming processes, right? You get the code, you compile the code. This is generating these packages that will merge and use SQL and this JavaScript libraries and handling dependencies and error checks. And then when you actually execute it, that will run in BigQuery. It's a very important difference between the development phase and the DevOps. Again, people, as I mentioned a few times, the approach is the classic DevOps, right? The development and the execution and operations here that happens in BigQuery. SQL transformations, materializations, whether they're manually or scheduled program. So you're going to create in, this is part of the lab, by the way. I'm going to be demoing these features. This is an overview, people. Let me clarify that I'm about to show you 3-4 slides going quite deep into the data form functionality. You're going to catch up with this. You're going to have more extra material as you move on to stage 2 of the program, and with additional labs and additional training material to cover that, right? But let's take a quick overview. The development part happens in workspaces. You're going to create a workspace with default files and folders. If you're familiar with GitHub, you're going to start recognizing some of the functionality, because as we are manipulating code, obviously Google would assume that you need to provision an environment where engineers or programmers are already familiar with, right? So using this structure of folders and directories to manage your files is very similar to the way that you do it in GitHub, for instance, right? Definitions, include folder, the git ignore, list files or directories to ignore during the commits when you're pushing the code to compile the code. Package JSON to handle dependencies. Remember those libraries that the code will need to run. Install packages with exact version. Version control is another very important component here, right? This is the file structure for this SQL Extended libraries. There is a config block, specify query metadata, document data, define quality test. The JavaScript block, reusable constants and functions. You have this component there. Pre and post operations. So you have the operations, the transformations here, the SQL body, what we call the SQL body. These are the transformations that we just mentioned that needs to happen using SQL. And what needs to happen first? This is purely about discussing these dependencies. What needs to happen before doing these transformations in SQL is pre-operations block, and what needs to happen after the transformation is a post-operations block. Again, this is typically associated with quality checks, for instance, right? So it's simplifying the code. One of the reasons why we want to use Dataform, we just mentioned that one reason is centralizing or unifying the whole end-to-end workflow. Instead of using different tools, we want to use the same framework. But the other thing is simplifying the code. You see an example here how code can be redundant SQL definitions and code can be replaced by simpler statements, right? So you see an example here in using a standard SQL and how it's going to look like when you implement it using SQL extended, right? With mapping, you're going to have some dependencies to include as well, right? Create table and view definitions that will compile, again, complex, imagine complex transformation, right? Here we are considering, and this is another important thing that could be relevant for the exam people. In addition to determining here which pattern you need to use, ETL or ELT, that kind of conversation that we are having here, you need to, as accurately as possible, assess the complexity of the transformation. Because yes, there is a possibility that this Dataform approach is kind of overkill, right? It's too much. You don't need this level of complexity in this framework to handle very simple transformations. We are processing, I don't know, you have invoices or orders in US dollars, and you need to convert that to euros or British pounds or something like that. Okay, for that kind of transformation, probably you're not going to need Dataform. Okay, here we are talking about transformations to the level that you may need to create temporary tables along the way, right? To compute the moving average or doing some complex transformation, right? So this is another very important thing that you need to practice about for the exam, is to properly assess the level of complexity of this transformation to determine which approach you would take, right? Data source, my table, incremental table, you have all of these. Create a table as above and updates it with new data. Again, this is the transformation being ingesting data and doing some processing along the way, right? Compiles, you're going to need to create views. You may need to create views that need to be materialized. If you're not familiar with materialized views in BigQuery, you will, because it's a very important resource available in BigQuery for performance optimization, right? Assertions. Assertion is when you define the quality rules. You specify a set of rules that will define what we mean by quality data, right? Not null checks, unique keys checks, custom logic. Those are the kind of functions that you want to assert when you specify the workflow here, right? And then you have some operations. Operations are associated with custom SQL, create a table, data manipulation language, machine learning, BigQuery machine learning. You may be using this data pipeline to retrain existing machine learning models. Dependencies is very important. When you're working with this workflow, you're basically having a conversation about how to identify and handle dependency, right? Dataform supports two. There is some kind of implicit dependency declaration that basically when you are referring to a table, that table must exist. That's the kind of direct, kind of automatic dependency. In order for me to use a table, that table must exist. Or explicit dependency will say, listen, we're going to do this transformation on this table. Obviously, that table must exist, but maybe there are other tables that must be there as well, just to make sure that when you perform that transformation, everything that is required is available. So you can explicitly specify which, well, dependencies in this case, but which tables need to be present before performing a specific task or step or transformation, right? So again, implicit versus explicit. Then you have the compilation. Once you specify in this workspace, when you have your directories and your files, your folders and your files, you need to compile that. This is this creating like the code that will be executed in BigQuery, right? And it's going to generate the graph. You're going to get this level of visibility. The compiled graph visualizes the SQL workflow. You see the customer source, the intermediate steps here. There is an assertion here looking for quality, and then it's going to generate two downstream processes. We are creating a view with customer data process. Somehow we don't care actually about the data, or maybe here we will have machine learning training. We are calling a function downstream that may retrain or retrain a machine learning model, right? All of these workflows that we create using Dataform can be scheduled and executed on this kind of recurring basis, this kind of time-based programming, right? We're going to discuss later on using Cloud Run functions, for instance, when you need to trigger this using a specific event or something like that. You have internal triggers, manual execution, or workflow configuration. You can do it in Dataform. Again, remember what I told you earlier about scheduling queries in BigQuery. This is great, this workflow configuration, but it's workflow by workflow. What if your company has, or your team has 50 workflows, 100 workflows that you need to maintain? Are you manually going one by one and scheduling them? That's when we need to consider external triggers, because using this Cloud Scheduler or Airflow or Cloud Run functions for that matter, you can centralize the administration of these schedules or any kind of mechanism that will handle this trigger when those data forms need to be executed, okay? So let me show you. Let me run the fourth lab that we have here, and I will demo Dataform. Due to some mostly time limitations, the transformation that we are implementing here is very simple. Again, this is probably not a good example when you are evaluating. This is actually a good example where maybe Dataform is not required, right? It's kind of overkill, it's too much. But again, because we have some limitations in time here, we cannot build something too sophisticated anyway, right? You will, though. You will. Again, when you move to stage 2 of the program, you have more labs to work with Dataform, BigQuery, and Dataform. So let me run this lab for you. Remember, people, that the labs are disabled. You are okay. Your labs are disabled here. Will remain disabled this morning until we finish by noon India time, and then I will enable them all, and you will have until the 22nd of June to complete at least 5. Any of these labs, 5 of them, you need to complete them by June the 22nd, you see, 11 p.m. You don't need us to share this information. You can find it yourself here using this dashboard. So now I'm going to open the lab because I have my demo environment naturally here for me to demo these resources. So let me check here. So I'm going to be sharing with you again the lab. The good news, people, remember from yesterday, is once you learn how to run a lab, you basically know how to run any labs because they're all the same, right? Not the lab, of course, the labs are all different, but the way that you run them is basically the same, right? So before you start the lab, you're going to have 1 hour, which is plenty of time. Look at this. We're going to create a Dataform repository, create an initialized Dataform development workspace, create and execute the SQL workflow, and view execution logs in Dataform. This is what we are doing here. We're going to start the lab. And again, I'm showing you this now. I'm going to go ahead and start the lab. So you will see that the lab is provisioning a set of credentials. And again, people, as we said yesterday, please, if you have your own credentials on Google Cloud, don't use them, okay? You must use the credentials provided by the lab, these temporary credentials that are going to be good for an hour. You have 1 hour to complete the lab, which is plenty of time, right? So before I log in Google Cloud, I will walk you through the different tasks, create a Dataform repository. Make sure, remember that you need to check your progress, okay? So you're going to have to check your progress. Before you finish the lab, come here and check that you are 100% completed, right? You have all, of course, it's going to fail for me because I haven't done anything yet. But before you finish the lab, end the lab, make sure that you have this, because this is what we will register that you actually completed the lab, okay? Until you get 100% here, completion, you are not, the platform will not record that the lab is completed, okay? So create the Dataform, and in order to achieve that, make sure that you follow the instructions to the letter, okay? If the repository ID field needs to be called like this. Please use that code. Copy and paste the content here from the instructions into the lab, okay? Because if you have a typo here, you use uppercase, lowercase, or different dash here, probably because I don't know what's happening when you check your progress here, it may fail. So to secure that we don't have that kind of problem, follow the instructions to the letter. Use exactly the same names and follow. And this is what I'm about to do now for you. So what I'm going to do here is to open the console lab setup. I'm going to click. Remember that you need to use an incognito window, okay? If you use the standard browser window, and again, Chrome is the recommended browser, but it's not actually required. You can use a Microsoft browser or Firefox, but if you do have Chrome, it is the recommended browser. Just open it in an incognito window. It's going to open a new tab here. Sorry, it's going to open a new window, not a new tab. And it will log you in automatically on the platform. Just make sure, only thing you need to do is to make sure that when you get logged in here is using the proper student account. Just come here and check that this student account is actually the one that the lab assigns to you for this run, okay? So now I'm going to follow the instructions. Okay, I'm not going to show you the instructions so you have better visibility here of my console. Let's see. Yeah, that should be good. So when I look at the instructions, it's telling me that first step after logging in and all of that is to create a data form repository. So I'm going to go to Google Cloud, BigQuery, and then data form and create repository. So let's do that. I'm going to go to the menu, scroll down. What is BigQuery? Here, I have data form right there, right? So I'm going to go to the menu here, data form, create a repository. It's empty, of course. Repository ID, quick start repository. This is the part I just mentioned. Please follow the instructions to the letter. It's telling me to use US East 4. You may have a different region depending on the execution, and that's it. Create. So once we have that created, copy and save the service account. You will need to use it later to assign necessary permission. This is important, right? You see the service account. There is a service account. You can copy. You don't need to copy. I don't copy the service account. The lab instruction is telling you to take this service account, so you can do it because you need to assign permissions. This data form job will need to use other Google Cloud resources, and we know that, right? In Google Cloud, in order for a service to access and talk, communicate with another service, must be somehow a way to authenticate and authorize that. The best way to do it is to use service accounts, and we have a service account for data form, and we need to make sure that that service account has the proper permission. Here it's asking me to do it, to assign. You need the following role. We are not doing it, okay? Just follow the instructions. We're going to do it manually because if you need to assign another permissions, it's important to learn how to do that. So don't do grant all here, just leave it. Go to repositories here. It's going to show you the repository. And the next step is here to the workspace. So we're going to open the repository and we're going to create a workspace. So in order to create a workspace, and I'm following instructions here, I'm going to open the repository and create a development workspace. The workspace ID is provided in the instructions. Just again, use exactly the same, create. Once created, we're going to initialize it. So we have the workspace, we open it, and then we need to use Project Quick Labs. What is the enable by visiting console? Let's see here. Initialize workspace. You can ignore that message. You saw the message I have. This is a warning telling me that there are some APIs that need to be enabled. Okay, you can ignore initialize workspace. Workspace initialize. And here you have this folder. Remember that we saw this in the slide. You have these folders, includes, definitions, git ignore, the YAML file for the configuration, and you have the codes here that we're going to be using. Again, the process itself, the transformations are not that relevant. We need to get familiar to get introduced to the studio here to create the workflow, right? Initialize, we did that already. Create a SQL file, a SQL extended file for defining a view. We're going to be running a view, or getting the data from a view, running a query actually as a view, and then process the data, right? In the files pane next to definitions, more and create file, and I'm getting the name of the file. It's called Quick Start Source SQLX. So I'm going to do that now. Definitions, you see definitions here, you have the 3 dots. Again, all of this is provided in the instructions. Create file. The lab will tell you the name of the file, which is Quick Start Source, create file. Here is a new empty file here. Define the view. And then you will see that the lab instructions will provide. This is the view that we are creating using this kind of YAML file, right? Kind of a JSON file. We are inserting, again, this is very simple. We're going to insert apples, oranges, pears, and bananas to a table, right? So create a SQL file for table definition. So let's create a new file. I'm going to need to take it here. Create a new file, go to definitions, create file, and we're going to create a new file, which is called Quick Start Table, create file. It's opening here in the center. And as we just said, go to the lab instructions and copy and paste the code, which is doing counting. Basically, the transformation in this case as very simply counting the per fruit, type of fruit, right? There is an error here. Compile queries. You see the error here. There is a warning on the top right-hand side. Just ignore it. Ignore the message and proceed to further steps to execute the workflow. We're going to fix that later on when we assign permissions. Grant data form access to BigQuery. This is the part that we need to assign permissions. In order for the data form workflow to access BigQuery tables, views, and all of that, it needs permission. This is something that Google uses. It's called Zero Trust Policy. Every service that needs to communicate with another service somehow will need to be authenticated and authorized. Of course, in Google Cloud, we know we do that using the identity and access management. So the next step is to assign the proper roles to this service account that was created when we created the data form, not the workspace, the data form repository, sorry, the data form repository. There is a service account for each data form repository. So let's do that. So I could leave, remember what I told you, people, I could leave here, go to the menu and select identity and access management, but then I will need to come back here to data form and reopen all of this. So I don't want to do that. What I'm doing here, and remember I mentioned this, I'm going to duplicate in my browser, in my incognito version of the browser, we have a tab with data form. I'm going to duplicate that, create a new tab. I'm opening a new tab here in my browser, and now I can use here and go to identity and access management. The lab instructions is telling me to go to IAM. It's going to tell me here that I need to grant access. Again, this is now you need to reference the data form service account that was originally assigned by the process when you create the repository, okay? You can type data form, people. For the lab, if you type data form in new principles, it will show you that. That's why, as I said, if you don't need it, you actually copy. Technically, in real life, you're going to copy because you may have multiple service accounts. So you need to make sure that you use the proper one. But in this lab, they have only one repository, so we have one service account, right? So I'm using it here, and you need to assign the lab instructions will tell you which roles we need to assign. One is the BigQuery job role. And in order to assign the roles, let me show you the best way to do it, right? Select the role. And of course, you can look for BigQuery here. I could look for BigQuery and then explore the different available roles, this predefined role. But it's better if you just search here on top, BigQuery job user. This is it, the first job role. I'm going to use another one, which is BigQuery data editor, because my data form job will need to manipulate the data. I'm going to need data editor here, data editor, and I'm going to add the third role, which is BigQuery data viewer. I'm going to add data viewer as well. And again, all of this, of course, is coming from the lab instructions, okay? Data viewer. Okay, those are the three roles that the lab is asking me. Let me show you. This is the lab instruction, and you will see I just did this, right? Task 5, grant data form access to BigQuery, and this is exactly what I just did. Assign these three roles here to the service account, to the data form service account. Save. Okay, it's saved. You could check if you want here, but now I'm going to switch. I'm going to go to the other tab, and still have my data form environment here, right? I'm going to complete task 6, which is in this case, execute the workflow, okay? In the navigation menu, data form, I don't have to do anything like that because I did it already, so I need to run it. Basically, I'm going to need to run it, right? So I'm going to go back here, start execution. And again, now people are following the instructions. Start execution, click start execution. Execute actions. Here you need to select all. Here again, this is, I'm just following instructions. Select all, leave all the items, the default value, and click start execution. Click start execution. I'm going to start executing the pipeline. Created the workflow execution there. So let's see here. That's it, guys. Now we can go here. Let's see executions. You can click on executions, and you will find that the execution complete, 4 actions, and you will see the different stuff, right? You have a view, and you can check if you want to. This is completed successfully. You can go here. You can go here. This is not part of the lab. What I'm about to do now is not included in the lab, but you can do it. You can go to BigQuery. Load the BigQuery, and here you can check your project. Must be a data set. You see data form. We didn't do this. We didn't create that, but you can find this quick start table. Remember that we specify, and you will see the fruit here. Bananas, pears, apples, and it's counting. This is what the lab, the data form did, right? And you have a view, a couple of views. This is all what the data form workflow created. And you have access, you can check all of this. Okay, that's it, guys. That would complete the lab. When you get to that point, I just show you here the execution, view the execution logs. And my lab, as I said before, people, please, super important, double check before I'm about to end my lab. I need to check my score. I need to secure that I have 100% in every single task, okay? If not, you can check your progress here, or you can go down here and directly check on the activity itself. But do not end the lab here before you verify that you completed all the tasks, right? Because remember, you need to complete 5 labs, and this is how Google Skills knows that you actually completed the lab, right? By checking 100% completed, okay? Once you're done, though, end the lab, and that's it. I'm done. I don't want to provide feedback. And that's it, guys. And then we go into demo the rest of the lab. If I go here, I'm gonna be working with the other labs. Again, the labs will remain disabled, okay? And this incognito window, what you see the console and BigQuery and Dataform, everything with it, just close it, okay? You just need to close it. You don't need to delete anything that you did during the lab, okay? So that's it. That's it. What we are going to do now, people, is to take a break. Let's go ahead and take a 15-minute break here, and then we will continue. We have 2 more short modules. I have a couple of labs to demo for you, and then I will enable all the labs, and you will have, again, until June the 22nd to complete at least 5. Again, if you are wondering which labs you will need to complete by then, those 5 labs, any of them, okay? Any of them, any lab, as long as you complete 5, at least. Again, I strongly recommend it that you do them all if you have time, because they're very useful, actually. Okay, 15-minute coffee break, guys. Enjoy. I'll see you in 15 minutes, okay? Remember, if you miss, for whatever reason, you missed yesterday's session or today or part of today's presentation, this YouTube session, yesterday's and today's YouTube session will remain available for you to watch for 7 days, okay? For 7 days, you will have access to this YouTube presentation using the same link that you used to connect today. Okay, welcome back, everybody. Let's go ahead and continue here. Our next module, let's review the agenda, okay? So we covered so far module 4. Today, the extract, load, and transform data in pipeline. Remember, we said one of the key factors to determine whether you want to use that approach, extract, load, and transform, versus the one that we are about to discuss now, extract, transform, and then load. Remember that by loading data, we mean in BigQuery. We are loading staging data in BigQuery. Is whether those transformations that we need to run can be handled in SQL, because as we just saw in the previous module, we are doing transformations using SQL, functionality available in SQL. If that is not possible, because it's too complex or the nature of the data that we are manipulating is not suitable for that kind of transformation, we need to consider the techniques that we are about to introduce now. Again, this is an overview, people. Again, we are about to discuss in this module 5 very complex resources, data flow, data Spark, running serverless Spark. Those are very complex frameworks that you may need to use to build these ETL pipelines. Okay, again, we are overviewing them here, highlighting the key capabilities and functionalities, specific use cases. And again, when you qualify for a stage 2 and to move forward with this program for preparing for the certification, you will have much more material available to, and labs as well, to cover this service. Again, we are doing an overview here. Okay, and we're going to finish up with automation techniques. We have 2 labs here. I'm going to demo one of them and another one at the end of the session with automation technique, and then I will enable the labs for you to start working. And yes, I still see comments in the chat, people, about labs being disabled. Yes, they are disabled. We'll keep this lab disabled, the 4 labs that we are working with today, until the end of the session. By noon India time, as we wrap up this second session, I will enable them all. If you are online by then, you will see me, as yesterday, enabling all of these labs. And again, you're going to have until June the 22nd to work with them. Again, you need to complete at least 5. Anyone, okay? There is no, these are the 5 labs that you need to complete. Pick anyone, 5 of them, and actually you can do them in any order, plus one at the time. Okay, this is, I think I mentioned this yesterday. Please do not run more than 1 lab at the time. As you notice, when you run a lab, the platform spins up a set of temporary credentials, and we notice that when the platform detects that for the same user account we have 2 sets of credentials active, sometimes must be some kind of abuse filter or something that may block your account. So stay away from that situation. If that happens, by the way, you could use this contact us here to request your account to be reset, and this is done usually rather quickly. But to avoid that, just make sure that every time you run a lab, you've completely ended any other lab that you may have run before. Okay, 1 at the time. 5 out of these 7 is the requirement by June the 22nd to apply or to qualify for the next stage. Okay, so let's talk about the extract, transform, and load data pipeline pattern. Okay, this is the module that we are covering now. Let me check here. I'm going to open the chat here. Okay, so let's talk about the architecture. This is the most complex of these 3 patterns, EL, ELT, and ETL. This is, of course, the most complex one. We are introducing, in the previous one, we are using BigQuery. Basically, you notice that we are doing pretty much everything on BigQuery once you connect with the external sources. Now we're going to need to introduce, we are basically, again, the way that you decide to move into consider these ETL architectures is when the previous approaches, the previous patterns that we discuss here are somehow not enough, right? You need something else, and we need to discuss this architecture. We are introducing 3 more products here. The Google Cloud GUI tool for ETL data pipelines, batch data processing using managed service for Apache Spark, and we're going to be looking at streaming data. Here, this presentation, and again, this is an overview, when you are building these data pipelines, you have two different frameworks, right? One is batch. These are the data pipelines that you can schedule to run on a regular basis, ingesting data from files. Those files are what we call a batch for the data pipeline. And then you have a streaming, data processing. This is something that you will implement when you have events, something that happens in your environment, and those events generate data, and that data needs to be ingested in the data pipeline, okay? So we're gonna be discussing here two products, Apache Spark, again, formerly known as Dataproc, people. If you have some experience with Google Cloud, Google just rebranded this Dataproc, which is technically Hadoop on Google Cloud, including, of course, within the Hadoop ecosystem, Spark, Apache Spark, that was rebranded by Google as managed service for Apache Spark. If you search in Google Cloud, on the search box there, Dataproc, it will bring you to the Apache Spark, right? So if you are, again, I'm just commenting on this because you still see documentation. Obviously, this new announcement, these new features, especially rebranding products that Google does quite regularly, by the way, but especially this part of the year in April and May, because it's when Google holds these two big conferences, annual conferences, Google Next for Google Cloud in April and Google I/O for developers in May, and they usually release and launch a lot of products then, right? So I'm mentioning this because when you go through the documentation, if you go online and work with the documentation in preparation for the exam, you may still see, I don't know, Cloud Composer. In the next module, the final module, I will tell you about Managed Airflow. Managed Airflows used to be called Cloud Composer until a month ago, right? So you still see those references in the documentation and some other resources, especially online. Google is, again, working on catching up. Eventually we'll get there, but be familiar with these different brands and different references to the same product, basically, right? And Bigtable, I'm going to finish up this module overview. We are not doing a lab here in Bigtable. You will see why when I overview Bigtable. You will see very clearly why we don't have a lab to run Bigtable, right? And let's talk about this. So Google Cloud provides multiple services for distributed data processing. This idea of distributed data processing is something we mentioned earlier regarding parallel, distributed, and parallel processing. Remember analyzing dependencies when we had that conversation regarding making sure that you understand dependencies between different tasks when you are building these pipelines, because if you don't see any dependency, that means that two tasks may be executed in parallel, and that's going to improve the performance, right? So we have UI and code-friendly tools. You have tools that you can build without coding. This is one of the, another thing for the exam, people. If you have, when here we are looking at which factors you may consider when you are deciding which tool you want to use. We mentioned already one of those factors, which is the complexity of the transformations, whether you use SQL-based transformations or another approach, which we are doing now. And the other thing is whether you need the UI, which means code-free or no coding. When you have a team that you don't have developers, programmers capable of handling, you will see here with the Spark. If you are familiar with the Spark, and you should be familiar with the Spark, people, if you're not, go ahead. You don't need to be an expert for the exam, but you may have questions in the exam. As I mentioned earlier, Google tests your knowledge not only on Google Cloud products, but other data engineering products, especially those open source like Spark. They're very popular, and therefore you may need to use them in your job, right? As a professional certified professional data engineer. So anyway, if you are working with these tools, you're going to need developers, because all of those tools, they are very powerful. You can basically implement any kind of transformation, but you're going to need people knowing Java, Python, Scala, those languages, right? So there are services available where you don't need that. You don't need to code anything. Products like Data Fusion and Data Prep in particular here are available where you can build complex transformations without the need to code anything, right? Open source, we just discussed Spark, Apache Beam, running behind Dataflow. Those are all open source, which is great for portability. You don't need to buy licenses. You may experiment. If you're not, if you're not sure which one you want to end up using, you can prototype them. You can proof of concept and you don't have to buy licenses to do that, right? So open source frameworks is very important in that sense. And using template, I just said, this is complex, right? You're gonna be dealing with complex scripts, coding in these programming languages, though Google complements the capabilities of these services with some templates that are available for you to use. Of course, you have the template that you can call it and use it with the proper parameters, attributes, or you can access the code. When you see template support, it means you can run the templates, you can use them as they are, or you can customize them, because you will find the link to the GitHub repo or the actual code in the documentation for the template. And of course, if you need to do some changes, some adaptations or customization, you could do as well. So that's why it's called template support for those two things, right? So let's look into the no code. When you look in Google Cloud GUI tools, again, this is for especially for teams, not necessarily, because even if you have a team of developers and programmers, if you can use this GUI, these user-friendly tools, you don't need to write code, could be very effective as well. Dataprec, be careful, okay? Here refers to Dataprec by Trifacta. This is the provider of this tool. There were some changes lately. Trifacta, the company, was bought by Alteryx. So now this product, even though it's there, all the functionality that you see here for Dataprec is still there and it's available, but be careful because the product itself, it changed the name. The branding now is called Alteryx Design. It's part of the Alteryx Designer Cloud. I don't know. This is a company buying another company, merging with another company, but it's there. The functionality is still available in Dataprec. There are some changes there on the name of the product, but the functionality is there, right? So we have multiple sources, predefined wranglers. You have a wrangler to manipulate the data when you work with these tools, and this is pretty much by design. The creator of the tool, Dataprec, the user interface looks a lot like a spreadsheet, like as if you were using Google, Microsoft Excel, for instance, as a spreadsheet, and that is by design. As I said, people working, not non-programmers working with this data manipulation, they usually feel quite comfortable using user interfaces like a spreadsheet or those kind of things, right? Dataprec present that kind of look and feel for the manipulation of the data. That process is called the wranglers, by the way. And it's creating this recipe. This is kind of an internal tracking of all the transformation rules. Right? You don't have to code. These recipes are automatically generated when you're building that. And then it runs data flow. We're going to talk about data flow, but the idea of using data prep, and you will see the same in the next slide when we talk about data fusion, is that you don't deal with the data flow complexity. As I said, the tool that we use to build this transformation is data flow, but you're going to need developers. You're going to need people properly trained to use data flow. If you don't have that kind of know-how, you can use data prep, and when you run a data prep process, it will, behind the scenes, run a data flow job without us needing to actually know and manipulate the configuration of the data flow. Again, we are making the complexity associated with running that service completely transparent for front-end users, right? Preview the transformations. You see how it looks like. You can have this user interface that would directly allow you to manipulate the data. You see this kind of histogram visualizations here when you're looking for outliers. As you can imagine, this is very useful for quality checks, for instance. If you're looking for null values, what is the distribution of your data for certain categories, have a very nice and direct way to see, to visualize that kind of thing, so you may make the right calls about cleaning or somehow preparing the data, right? Data prep, this new Alteryx or data prep, is for data manipulation, to implement the transformations. If you need to, again, without coding, without programming anything, you need to build an end-to-end data pipeline from connecting to the sources, to transforming doing transformation, and then loading the data into things. You can use Data Fusion. You can use Cloud Data Fusion. It's a GUI-based enterprise data integration service. Again, this is a company that Google bought a few years ago called CDAP. This is very different from data prep, people, by the way. Data prep is kind of a partnership that Google has with the provider, Alteryx or Trifacta, whereas Data Fusion using this platform for building data pipeline now is fully integrated into Google Cloud. CDAP, if you see CDAP is the name of the company that Google bought for this product, okay? And you build this DAG. DAG is directed acyclic graph, and it's the pipeline. It's essentially the pipeline. It's like building a visualization, dragging and dropping. You see a panel on the right-hand side. You have your sources, you have your links, you have your syncs, you have your analytics transformations, and you will drag and drop them into a panel, a studio, and build visually. You can build your pipelines without, again, minimizing or eliminating altogether the need to code. You actually programming this. Behind the scenes, remember that we saw data prep. Behind data prep runs data flow. When you actually execute a Wrangler in data prep, it's actually using data flow. Data Fusion, on the other hand, is using Spark. It's internally provisioning a Spark cluster using Dataproc. It used to be Dataproc, now it's called Managed or Serverless Spark in Google Cloud. But again, the idea is to use these front-end services, data prep or Data Fusion, to build these pipelines without coding, without programming. This is, again, code-free, code-less approach of building this data pipeline. If you are wondering about what is the relationship, the connection between data prep versus data fusion, remember, data fusion builds the end-to-end pipeline. Probably the data prep Wrangler is part of the data pipeline. So you build your data pipeline and the whole workflow from sources to syncs using data fusion, and inside part of the pipeline, the transformation may be potentially implemented using data prep. So data prep will be part of the configuration of your data workflow, your data pipeline, right? And they're completely independent products from each other, of course, right? This is how you build, right? When you build a data fusion pipeline, it's going to look like that. We are connecting, and of course, the reason I mentioned that is CDAP, which is the original provider of the tool, is because, again, this platform comes from a vendor, a provider that was completely independent from any other cloud provider, right? And this is important because you will find hundreds of connectors or plugins that would allow you to build your data pipeline ingesting data. You see an example here, bringing table from the SAP, which is the ERP product that, of course, everybody knows, right? And then landing the data in BigQuery, joining the data, merging the data here, doing some transformations here, sending data to cloud storage, sending data to BigQuery. You build all of this, just dragging and dropping all of these components, and then, of course, you can edit them and configure your data flows and all of that, right? But you're not going to need to write one single line of code, I don't know, in Java or Scala or Python. That is usually what you would do if you would build this using Apache Spark, which we are about to discuss now, right? So again, the first approach here, looking at data prep and data fusion, is intended for those teams that they don't have the proper know-how internally to handle this complex transformation. If you do, if you have developer familiar enough to handle the complexity of the workflow, you can use the options that we are about to introduce now, right? Apache Hadoop and Spark workloads on managed service for Apache Spark, again, formerly known as Dataproc. If I go here to the console, my demo environment, and I look here, because serverless for Apache Spark is kind of a mouthful, right? So if I look for Dataproc, I'll leave for a while, it's going to point me to manage Apache Spark, right? You can see it right there. And of course, it still has the previous functionality of Dataproc. So if you want to create a cluster, Dataproc, the original Dataproc, would allow you to create a cluster, a managed service where you can create, and by creating a cluster means specifying the machine. See here, I can go and specify what kind of machine I want to use for my worker configuration, the type of machine, the memory, RAM, storage, number of cores. You have full control. This is still available, okay? This is, again, this is coming from the previous Dataproc service on Google Cloud. And now we are talking about this serverless. You see the option here, serverless, and using these batches. In the next lab, I will show you how this runs. But here you're going to create the batch. And the idea of serverless, this is typical on cloud platforms, is that you upload your code, your data, what you need to do, and that's it. The service somehow will run it, will provision the required resources. You see there is no configuration here for the machine that you want to use and all of that, right? So you can still access, again, the reason why people, and again, the reason why I'm mentioning here a few times already the previous name, the reason why I'm mentioning the previous name of all of these products is because you still run into documentation material that you will need to access when you're preparing for the exam. Still, again, Google is in the process. It's a work in progress regarding updating all the documentation with the new names, right? And the exam, I wouldn't be surprised, by the way, if you take the exam within the next couple of months, that the question is still referred to Dataproc or Cloud Composer, for instance, instead of using the new managed Airflow name, right? Run your Apache Hadoop and Spark workloads on managed service for Apache Spark. The idea from Google is this. It's very likely, and this is relevant for the exam as well, looking at the specific use cases that may be presented in some questions, is that what we are doing here is migrating. There is already a data pipeline running somewhere, on premises, on another cloud provider, in another project in Google Cloud, I don't know, anywhere else, right? And we need to run it on Google Cloud. We need to bring it into Google Cloud. So that's the idea. If you use Apache Hadoop or Spark, it's very popular, of course, open source. You see, Apache means that it's using the Apache licensing, which is obviously open source. And the idea is to bring those workflows on Google Cloud, and you run it. Somehow the service, this new serverless resource, will figure out how to run your jobs, okay? Of course, you need to consider some ways to optimize. After bringing your code and start testing it in Google Cloud, you might be considering optimizing that and moving for probably, especially on premises, you may be running persistent disks using HDFS. HDFS is the Hadoop distributed file system. It's the file system used for any Hadoop framework that you run, including Spark, of course, but not only Spark. I don't know, Hive, Presto, MapReduce are another examples of popular frameworks available within the Hadoop ecosystem that you can run on Dataproc, by the way, on this serverless Apache, by the way. But it's very likely that those HDFS that you are bringing kind of a lift and shift approach from on-premises on persistent disks in Compute Engine, you may want to replace it by cloud storage, by BigQuery, by Bigtable, these native cloud solutions, of course, right? You need to consider using for performance optimization. So that is a process of migrating. By the way, cloud storage is fully compatible with HDFS. If you have Spark jobs referring to data on disk with the HDFS reference, you can replace directly that HDFS by GS. GS is Google Storage. And that's it. It should work. Of course, you need to load the data from your disks into cloud storage. But once you do that, just by changing any HDFS colon reference to GS colon reference, it should work because cloud storage is fully compatible with the HDFS format. Managed service for data processing with Hadoop and Spark. Again, Hadoop is the whole ecosystem with multiple tools, hundreds of them there, and Spark is one of these frameworks and probably the most popular one, right? I'm pretty sure that is the most popular one. Runtimes, Compute Engine, GKE, Kubernetes, serverless for Spark. There are different ways to run Hadoop on Google Cloud, right? Workflow templates with dependencies. One of the key concepts, let me comment on something that could be relevant for the exam that is not part of the material. Yes, it is. Sorry, it is. It's right here. Permanent and ephemeral clusters. This is another key decision that you may need to do as a data engineer, especially if you are migrating an existing Hadoop platform running on premises, right? The decision is whether you need to keep that cluster as a permanent cluster, I mean, up and running all time at all times, processing data, or you want to use an ephemeral cluster approach, which means that the cluster will be created in Google Cloud whenever you need them. Okay, you need why? Well, of course, because I don't want to pay for services that I don't use, right? If I use a permanent cluster, that means a group of virtual machines up and running, and Google is charging. We are paying for those virtual machines. Doesn't matter whether you are running something or not, right? So that's probably not ideal because, as you know, the mantra on the cloud is pay per usage. You want to pay only when you use resources. So sometimes you may consider ephemeral cluster. I say sometimes because if you have a job that is continuously running, processing data all the time, of course, a permanent cluster is the way to go. That cluster will be pretty much all the time busy processing something. So it makes sense to use permanent cluster. But in some other cases, no. Clusters are these jobs are running, ingesting data once a day, a few times a day. They're usually down over the weekend or late at night, outside business hours. So in those cases, when you have jobs that will be running using that kind of scheduling approach, you may use ephemeral cluster. Again, a cluster that is created only when you need to run a job, right? And that's why you need workflow templates. This workflow template will make sure that you attach this ephemeral cluster to these templates, and they can automatically provision all the resources, right? Because a cluster is a group of virtual machines. It's okay, but it's useless because until you deploy and install all the software, dependencies, libraries that you need to run. Again, you can do it manually, or you can use these workflow templates to do that, right? And again, it's not only Spark, okay? Open source ecosystem, Hadoop, Spark, Pig, Hive, Presto, those are all supported, right? You configure your Spark cluster, Apache Spark, manage nodes, primary workers. Secondary workers is using a Spot. This is a question from the exam, people. Almost guaranteed that if you have a question about Apache Spark or Dataproc, and the question is about cost optimization, you may consider the option of using secondary workers. Secondary workers are Spot or preemptible virtual machines, which are temporary virtual machines that you can deploy, but if Google needs them, they will take them. So they are virtual machines that we may lose at any time because Google needs them and will come and take them, right? And why? You may use these secondary workers as Spot virtual machines on Google Cloud because of the price. It depending on the resource, but sometimes Google offers something between 70 and up to 90 people, 90% discount. If you pay 10 for a regular standard virtual machine, you may pay 1 or 2 for the same configuration for a Spot virtual machine. Yes, it's true that Google can come and take it, but if you create your cluster with a number of primary workers, say 10 primary workers, and then they say, I'm going to triple my capacity for my cluster. I'm going to add another 20 with the Spot virtual machines. Again, you are multiplying the capacity of your cluster to process data for a fraction of a price. If you have a question in the exam that refers to using a Spot or preemptible virtual machines, these temporary virtual machines with huge discounts, the only reason why that's a good option is when the question explicitly mentions cost optimization. If you have a question in the exam that doesn't mention at all that you are doing something in order to optimize the cost, you are paying too much, your management is not happy with the price of running this, if you don't see anything similar to that in the question, and one of the options in the multiple choice is using a Spot virtual machine, that's not the right answer, okay? It's the only reason basically when Spot or temporary virtual machines could be an option in a question in the exam is because the question explicitly asks us to do cost optimization. Because again, you can lose those virtual machines. It's going to affect the performance, right? Need to, as usual, trade off, balance cost with performance or capacity. Persistent storage, you can connect, of course, with disk, hard disk, solid state disk, huge difference in pricing. Be careful here. Or persistent storage. This is called off-cluster storage. When you configure this HDFS, persistent disk is cluster storage because those disks are attached to the virtual machines inside the cluster. So it's in cluster storage. If you instead connect your processes running on cluster, Spark jobs running on cluster with cloud storage, BigQuery, or Bigtable, depending on the kind of data that you're running, that is called off-cluster storage, which is very important, as you can imagine, if you have ephemeral. If you have an ephemeral cluster, you may want to use off-cluster persistent storage, because when you delete a cluster, when you don't need it anymore, usually, unless you handle the configuration specifically for that, all the disks attached to those virtual machines inside the cluster, those workers, will be deleted as well. So you're going to may lose data. You need to be very careful when you're working with ephemeral cluster, right? Dataproc workflow templates. This is what I just mentioned before. When you create in this YAML file the list of steps, tasks, this is not too different conceptually. Of course, it's a different product altogether from Dataform, that you specify this list of dependencies and you automate the process. You deploy the cluster, you call the Dataproc workflow template, and the template will provision all the steps, not only the configuration of the cluster, but the job that needs to run, some monitoring services, the whole handling the whole operation of the cluster, basically, right? Apache Spark, of course, has nothing to do. Remember, I told you, yes, as a certified professional data engineer, you must know a lot about Google Cloud products and services, but that is not enough. You're going to need to learn about other products, especially open source services like Apache Spark, to work with in our environments, right? So Apache Spark is probably the best example of this. Be familiar with Apache Spark. Obviously, you don't have to be an expert and know exactly how to configure, but be familiar with these components at least, right? The Apache Spark, you have a data frame, the concept of data set, data frame, RDDs, you support SQL, streaming data, machine learning libraries. Again, just be familiar with the overall architecture of Spark and key use cases where Spark could be particularly suitable, considering this multi-cloud or hybrid environment, right? Model training, batch inference, graph processing, geospatial analysis. Those are the functionalities that you may be reviewing in preparation for the exam. The idea of using serverless Spark is this: run workloads without cluster management. Everything that we just discussed will require somebody from DevOps within the team to administer the cluster. Keep an eye on the cluster, operate. This is purely about operation, right? That's not going to happen if you use serverless Spark. Auto scaling, you see here, write code and execute. That's the idea. Conceptually, that's the idea. Auto scaling, no infrastructure to tune, no clusters to manage, pay for execution time. Google doesn't charge if your serverless Spark is not processing anything. No resource contention. You have all of this. It's all fully managed by the service. Now, be careful, okay? You may think that given these two options, Apache Spark serverless is always the best option because of all of this, that you don't need to administer or run or operate any kind of infrastructure. However, it is true that in reality, in real life, many teams, depending on the criticality or certain specific requirements, they need to control the cluster. In some cases, the team needs for certain specific jobs, they need to keep control on the cluster, especially those jobs that you need to run. They are heavily affected by regulations, policies, some kind of compliance requirements for legal reasons or things like that. So in some cases, for instance, you need to manage a special encryption algorithms or handle encryption keys. In those cases, you may use this managed service, the conventional, the before you see here managed service, okay? So do not assume that the new serverless is here to replace altogether the existing or any other possible execution of Spark, right? More than likely, companies will have both. You're going to have services running on managed clusters and some other services running on serverless, right? Depending on the application. Provides batches. This is the part I just showed you. You're going to be creating a batch. When you're using serverless Spark, you don't administer a cluster and workloads inside the cluster. You handle the batch. We refer to the code that you need to run and any reference, of course, to the data, right? You have interactive sessions. Of course, you can use Jupyter Lab as usual. You can use Jupyter Labs because you're going to need to manipulate the code and configure the code, and you can run some verifications online and those kind of things. Whether it's cost efficient, yes. The answer is yes. It's cost efficient. Only pay for execution time. However, you need to test. Okay, there is no right answer, right recipe regarding the cost. You need to explore the different options. But technically, yes, it's cost efficient because, again, once you run something, Google will charge for that. If you're not running anything, that's a free service, right? In that sense, yes, it's cost efficient. Integration. Obviously, the reason why we want to use Google Cloud is because you may need to use BigQuery, you need to use other services, cloud storage, relational databases. I don't know. There are a whole ecosystem of products and services in Google Cloud. Obviously, is fully integrated here. Logging, monitoring, observability in general. When you need to work with complex workflows, you will see in the next module talking about Apache Airflow on Google Cloud and how you can create DAGs, create workflows in Apache Airflow, calling Spark jobs, right? There are, of course, full integration there. Life cycle of interactive notebook session. You activate the session, you shut down, create, and you keep iterating, right? This is, again, provisioning resources to run your code in a notebook environment. So there is another lab here that I will run now for you. This optional. I'm going to run this lab because there are a couple of things that may happen in this lab that I want to show you. Okay, so let's go ahead and run this lab. Let me go here. Remember, people, again, that the labs are disabled for you still. Okay, they will remain disabled until noon India time. We're going to enable them in about an hour and a half, something like that. So our next lab here is this one. I'm about to demo now this lab. Use serverless for Apache Spark to load BigQuery. What are we doing here? Configure the environment, provide, you will run a batch workload on serverless for Apache Spark environment. The workload will use a template to process an Avro file to create and load in BigQuery table. Avro files are very popular on Hadoop environments. It's very likely that if you're working with the Spark or any other Hadoop framework or tool, you're going to be working with Avro or Parquet, for that matter, is another very popular data file. You can use CSV files or JSON files as well, but Avro files are particularly prevalent in this kind of Hadoop environments. We're going to configure the environment, download lab assets. Remember, people, that if you are not a coder, if you're not familiar with Python, Java, most of the code is used Python here. Don't worry, okay? We are not in these labs, and for the exam as well, for that matter, you don't need to know how to code. You're not going to have questions in the exam asking you to select specific functions in Spark or Scala or Java or those languages, right? In this case, all the lab assets will be provisioned automatically. Let me go ahead and start the lab as usual. Here, you may have these things here, so I'm going to check. Verify you are a human. I hope it works, because Google has been, I don't know if you noticed this when you're creating an account in Google Skills, but in the last few days, they're having some problems with this reCAPTCHA there. So it looks like it's fine now. But anyway, let me walk you through the options here in the lab. Start the lab, all of this we know. Complete the environment configuration task. We're going to be using Cloud Shell here a lot, right? We're going to be using Cloud Shell a lot here, installing, creating, configuring network resources here, creating, make bucket, creating a bucket, create a bucket for temporary location. We're going to create a BigQuery. We are basically, in this process, we are taking Avro files from cloud storage I'm gonna load BigQuery tables, okay? So we have here a data set that we are creating in BigQuery. Download the assets, you're gonna see that there is a virtual machine here, and we're gonna be running this on a virtual machine, okay? You will see me in the lab running all of these commands. Again, I'm showing you I'm walking you through the lab instructions now, and then I'm gonna switch my view here. I'm gonna show Cloud Shell. I'm gonna be working with all of these resources, okay? Okay. This is what we are doing. Just give me 1 second. Let me set this up. I'm going to go ahead and log in. Remember, you open this in an incognito window. And in this case, I will need to share my whole screen. Just give me 1 second here, because as we are gonna be using a terminal window here, let me log in. Just hold on. I'm going to share my entire screen. Okay. Okay. I'm gonna make this a bit larger so you have better visibility here. Just give me a second. There you go. This is my console. So let me go ahead and what I'm going to do here, and this is something I would recommend doing, especially in this lab that we are using Spark, and then we are using cloud storage, and we're using BigQuery. We're gonna be using different products. So instead of switching back and forth, I would recommend, again, this is totally optional. This is just a tip that I'm sharing here with you people. If you wanna use it, use it. If not, that's fine too, right? But I like to use 3 tabs here. In one tab here, I'm gonna run Cloud Shell, and I'm going to be running the lab instructions because most of the tasks here are using Cloud Shell, which makes sense because this is usually how you're gonna do it in real life, using Cloud Shell and using the command line interface, I mean. And in this tab, I will show, I don't know, cloud storage, because I'm gonna be looking at content that we're gonna load in buckets. And the third tab here, I will keep it, probably gonna use BigQuery later on to show you how we load the data, right? But anyway, let's go back here and let me follow the instructions here. The first step for me is to configure private IP access. We're gonna need to configure at the network level here. Let me make this a bit bigger. I can enlarge. As you can see here, I have a larger font for the command line interface. We are running that for the network. Then we're gonna create a bucket. We're gonna create the bucket. With the bucket is named as the project ID. Remember that bucket names must be unique. One of the best ways to secure that the bucket name is unique is to use the project ID. You see this Quick Labs is the project ID I'm getting from my lab, and which is also unique. You cannot have duplicated project IDs. So that's why you see that most of these labs, they use, when you create the bucket, you use the project ID because again, secures that you have a unique name. And we have another bucket that is called temp, BQ temp, okay? And then finally, we're gonna create a data set in BigQuery. So run the BQ command, MK, to create a data set in BigQuery. As I said before, I don't have to, the lab is not asking you to do that, but if I go here to the buckets and I refresh, I should see the 2 buckets that we created, which are empty. For the moment, I can check, and the buckets are empty, but that should change in the next task that we complete here. So let me go ahead and go ahead. We're gonna download the assets. So in this case, we're gonna do it using a virtual machine. This is interesting, people. I'm going to minimize here the Cloud Shell. I'm not gonna use it for now. I'm going to go to Compute Engine. And again, this is me following the instructions from the labs, okay? Virtual machine. And there is a virtual machine that is provisioned automatically by the lab, okay? There is already a virtual machine that is provisioned. It's called lab virtual machine. And we're going to SSH. We're going to establish a secure shell connection. It's going to open a terminal window here where we can interact with this service. It's going to authorize, and it's going to log me into the virtual machine. I like this approach because it's probably how you would do it in real life. Let me make it a bit larger here so you have better visibility. Maybe large here. But this is how you may end up doing it in real life, using a terminal somehow to install that. Normally in real life, your IT security team is not going to let you use Cloud Shell. So probably you're going to need to use some kind of virtual machine. We're going to install, again, the code itself. And this is also mirroring what may happen in real life. Right? You're not going to be responsible for actually coding the transformation. The development team is usually responsible for programming, coding the transformation, right? Our role as a data engineer is to run it, to check it, maybe test it, validate it, and run it. And that's exactly what we are doing here. We're going to assume that somebody created this Spark job that we are about to run. And here we are as data engineers running these jobs, okay? So I just downloaded there, download the Avro file. This is an Avro file. I just download, I can show you here that we have a campaigns Avro file. This is the file that we are planning to push from cloud storage into BigQuery using a Spark job, okay? So I'm going to move in the next line. I'm going to move the file to the bucket in cloud storage. And again, you can check if you want to. You can go here and refresh and look for the bucket. And you will find here, again, don't forget to refresh, okay? You will find this is the file that we just downloaded. Yeah? You can follow along. Again, the lab instructions is not explicitly telling you to do that, but if you want to, you can go to the console and check that what we are performing here is actually working, right? So now I'm going to download the Spark code. This is a zip file that contains the Spark code. This is what I told you, right? You see Dataproc. The reason why I'm insisting here that the previous name of serverless Apache Spark was Dataproc is because of this. You're going to find still a lot of resources that you will be using referring to the previous name of the program. And that will happen with another services as well, right? So I'm going to extract the file. We are extracting the file here. Okay, next. We go to the directory. We're going to go to a different directory, which is this. I can do an ls and check. These are all the files that we're going to be running, right? This is the Python. In this case, you see we are using Python to run this. Could be Python, could be Java, could be Spark, Scala. There are different languages that can be used. So next step. So set environment variables, people. Let's configure some environment variables. So I'm going to clean here the screen so you can see here that I'm setting up as usual. By the way, the project, the region, the staging location, which are the buckets that we just specify. As you know, these services, remember I told you yesterday when we talked about cloud storage, I told you, you are not going to be able to do anything in Google Cloud without using cloud storage, either because you use cloud storage to store your data, or because you use another product in Google Cloud, in this case Spark, and is using cloud storage. This serverless Spark does use cloud storage to stage and files and directories and temporary content in cloud storage, right? So next step here is run the following code to execute the Spark job. And this is the part I wanted to show you, okay? We're gonna run it here. And this may happen when you run these labs using these temporary credentials. Sometimes there are some limitations in the way that these temporary accounts, you know, get permissions properly propagated. It's a matter of time, basically just waiting. When I run this is me running the job, okay? We are running the start shell here. This is the code that contains the Apache Spark job, and we will run it here. And it's gonna start running. And hopefully I'm gonna get an error. I'm hoping to get an error because I will show you that when you get an error here, you may have some warnings that you can ignore. This is basically commenting on some libraries that are getting deprecated that we are not using here, so that should be fine. But if you get an error here and you just need to wait, try again, okay? What I said, when you have an error in this kind of batch jobs, you can wait and then run it again without changing anything. It's a matter of time. Again, it usually takes a few seconds, maybe a minute or so for certain permissions to be properly propagated. So let's see what happens. You see the batch job has been submitted. And if you want to check, people, again, this is another thing that is not included in the lab instructions, but if you want, you can go. We have another tab here in the console. I go to Dataproc, as I showed you before, managed Apache Spark. And here you go to batches, and you should see this. This is the batch that we just pushed, people, and you can see it here running. So let's see. See, it's running, status running. So we can wait, but this is, again, this is not specified in the lab instruction, but feel free to do that and you can check the code. Here is running. You will be able to see login data once this is done. But this shows that the batch is running, okay? Just we need to wait, basically here. It's gonna take a minute or so. And then you can go here to BigQuery and be prepared to check if the data is there, right? So you go to the BigQuery Studio. And for now, we have a data set with the campaigns. It's working. I can tell it's working because this campaigns table that you see here was created by the Apache Spark job. And let's see if we have data. And you have data as well, right? So I know it's going to work because it's already populating data. So you can follow the execution of that particular process by navigating the services that we are using in Google Cloud. Anyway, let me go here to this batch job. Succeeded, complete, is done, green check. If you want to check the logs, you can scroll here and you're going to see some metrics here. You have all of this, right? It's going to show you if you have this is useful when you have an error, right? Because you can go ahead and check here the login entries associated with that. If I go to the terminal window, of course, completed and successfully run Spark command, run successfully, okay? So run successfully, that's okay. Next step in the lab instruction is to run in BigQuery. As I show you, you can go to the console and run BigQuery, but in my case here in the lab is asking you to do it in the terminal, which is interesting. In some cases, you're going to have users that they don't have access to BigQuery. What we just saw here, that you go to the BigQuery Studio and query the table. This is something that in real life, sometimes the data engineer doesn't have access to that. So you need to interact with BigQuery using this command line interface. And this is the data, of course, that we just saw. As I said, we don't care much about the data. And that's it, people. When you do that, you would technically completed the lab. Here is the lab instructions. I get to the end. Again, before I end the lab here, I'm going to go up and make sure that I check my progress in every single step. Better if you use the top score here and make sure that you check your progress, and you should get 100%, right? Before you end the lab. Score 100 out of 100, nice. That means that I completed the lab, and now I can safely end it. I'm going to end the lab. Okay, that's it. We have 2 more labs. I'm going to demo one more, okay? The next one, streaming data pipeline using Dataflow. I will show you that lab. I'm gonna show you the instructions, but I'm not gonna do it. I'm gonna go to the next one because I'd rather finish this presentation and enable the labs. Remember that the labs are currently disabled, so I'm gonna enable them by noon today, India time, and then you can work, of course, on that. Okay. So let me close here. Remember that everything that we created during the lab, the virtual machine, the batch in Spark, the data set, the bucket, don't delete anything, right? Just by ending the lab itself will deprovision, delete all of those resources. You don't have to do anything yourselves. So let me continue here. We are on the same module, okay? We are not changing module. We are still on module 5 here. So let's talk about streaming, because this conversation we just had about using serverless Apache Spark was focused on batch. Even though you can implement streaming, remember that Spark does support the product. Spark does support both batch and streaming. We just see here we work with batch, but you could build Spark jobs running in a streaming mode. But here in particular, because we need to introduce another product on Google Cloud to build data pipelines, and again, batch or streaming both, but in this case, we're going to discuss the streaming analytics use case. We're going to use Dataflow to do that, right? So batch processing versus streaming data processing, people, very important. Processing analysis happens and set of stored data. The key difference is this. You're going to cover a lot of material in preparation for the exam on stage 2 regarding batch versus streaming, but the key idea is this. A batch is a batch data pipeline is a data pipeline that processes a fixed amount of elements. There is a batch, and that batch contains the first element and the last final element. In other words, it has a finite number of elements. You may have one element in a batch, you may have 1 million elements. Doesn't matter how many, but there is a first element and there is a last final element. That's why we said it's a finite data set. Streaming, on the other hand, is what we consider an infinite data set, meaning that you start the streaming pipeline ingesting data. That is, you have a first element, the first data element that comes through the pipeline, but you don't have a final end last element. That doesn't exist, because as long as the pipeline is up and running, it's continuously processing data, right? So this is associated with this idea of dealing with an infinite data set. Many decisions associated how to process your data in a streaming data pipeline are based on this concept that we are dealing with an infinite data set, right? So that's it. Fraud detection, intrusion detection. The other key concept is, instead of having a batch in a streaming pipeline, we have events. And this is a super important concept that you will be working a lot in the exam, in preparation for the exam, is event data. We are generate data. The typical use case that you see, and you will see a lot about this in the training material in the next stage, is IoT, Internet of Things, right? When you have sensors or phones, mobile devices sending data, sensors collecting room temperature and sending those measurements on a regular basis to the back end, or I don't know, cameras taking pictures on big cities, traffic, cameras taking pictures of traffic conditions and then sending those images to the back end, is analyzing traffic jams or those kind of things. Those are examples of streaming ETL workloads, right? These sensors are collecting data somehow from the environment and sending that data at any time. This is the idea of an event. We don't know when, we cannot anticipate. That's why we need to build this data pipeline to continuously ingest data. You're gonna learn about the product to build this streaming, especially ingesting data, that is called PubSub. PubSub is we don't talk much about PubSub here. It's a great product. It's a serverless product, very similar, and this is useful for me to comment on another product similar to Spark that you need to know about. Even though it's not part of Google Cloud, because what Google Cloud has is PubSub, there is another very popular, similar messaging platform available open source within the Apache ecosystem that is called Kafka, Apache Kafka. And again, like Spark, Kafka is not owned by Google. It's open source, by the way. Nobody owns Kafka, the community does. But you need to know about Kafka. Like Spark, as I mentioned before, that you need to be familiar with the product, be familiar with Kafka as well, because actually Google is investing a lot in connectors that can integrate Kafka messages into the Google ecosystem, right? PubSub is the one that we are presenting here. PubSub is a publisher subscriber, right? This idea of a service sending a message, that's the publisher, and other service or services receiving those messages. That's what PubSub does. And Dataflow is the product that we want to use here, like Spark. In the previous section, we discussed Apache Spark. Here we are discussing Dataflow. And then the backend is always the same. It's either BigQuery or Bigtable, right? Use PubSub to ingest high volumes of event data and distribute the different consuming systems. It's an asynchronous messaging platform. You have publishers, you see here on top. In this example, HR system, vendor office, they are sending events. These are events. A new employee. The HR department reports a new employee joining the company, right? This is an event that will require the system to do something. The vendor's office reports another event. A new contractor, a consultant, a trainer is coming to the office to work with us, okay? It's an external consultant. It's a new event. So when that happens, when any of these events happens, batch activation is required, facility system, these people will need a place to sit, to work, a desk, a computer, a phone, I don't know, those resources, account provisioning, the employee, the salary, taxes, benefits, invoices, contracts for a contractor, account provisioning, and all of that, right? So these are the backend services that they need to be notified every time an event associated with new employee or new contractor happens, right? PubSub is what you see here in the middle, right in the middle, right? Serverless. You don't have to provision anything, just start sending messages as a publisher to a given topic. Another important, PubSub is very simple, people. There are 4 components of PubSub. You have already 2 coming from the name itself, publishers and subscribers. Then you have a topic. A topic, like in Kafka, is like a category or kind of a container where all the messages that are somehow related, for instance, all the new employee events will be sent, those messages, to the same topic, whereas new contractors may have a different topic there. And that's it. Then you have subscription. Subscription is the mechanism that will take messages from topics and send it over to whoever is subscribed to that particular topic, okay, via the subscription. Again, you're going to go much deeper in stage 2 on PubSub. It's a very important, very relevant product, especially building streaming analytics related workflows. And it's pretty amazing, actually. It's one of my favorite products in Google Cloud, by the way. So the subscriber, let's forget about PubSub. We are ingesting data. Somehow we are collecting these events, and we will subscribe to one of these topics to receive events associated with a new employee or new contractor, for that matter. Doesn't matter, right? Data flow can process batch and streaming. This is what I mentioned before. In this session today, we are using Apache Spark to work with batch data pipelines, and here now data flow to work with the streaming, but keep in mind that Apache Spark supports both batch and streaming, and data flow also as well supports batch and streaming. In this case, we are discussing streaming, but you can do batch with data flow as well. Actually, and another very important difference that you need to understand very well, there are two products here. One is Apache Beam, which is the programming model. You design, you build your code, you develop your data pipelines using Apache Beam. It's the programming model, and you have 3 or 4 programming languages available: Java, Python, Go, TypeScript. And then when you run it, once you write the code, very similar to what we said earlier with the Spark jobs, that somebody writes them and then we use them, we run them as data engineers. Similar thing. Somebody will write the code using this programming model called Apache Beam, which is open source. You see, Apache is actually part of the Hadoop ecosystem as well. And then you may decide to run that code written for Apache Beam in any platform that supports compute resources to run Apache Beam, right? If your decision is to run that Apache Beam workflow on Google Cloud, then it's Dataflow the product. So Dataflow is the runner. Many people think that Apache Beam and Dataflow is the same thing. This is when you use Apache Beam on Google Cloud, it's called Dataflow. No, Apache Beam is what we use, is the programming model, the programming framework that we use to code, design and code the pipeline, whereas Dataflow is a different thing. It's the runner. It's a resource that will take the code in Apache Beam and provision cluster. That Apache Beam is doing exactly, Dataflow does exactly what serverless Spark does in Google Cloud. Provisions a cluster automatically of workers, virtual machines, to run, in this case, Apache Beam, right? You have an example here. Again, you don't need to read, but read from PubSub, map, there are some functionality. You see the functionality, the code that is actually doing transformation. Remember that what we are doing here is transforming the data using the Beam, right? Look at the code here. It's using Beam.map. The function doesn't matter. In this case, it's map, but it's calling the Beam module package to do that. Again, we are coding the transformations. All of that functionality is available within the Apache Beam programming model, which is completely independent from Google Cloud or Dataflow. It's community maintained, it's completely open source, right? And then you see the other components, read from PubSub. We are reading messages from PubSub, and we are writing to BigQuery. That's what we are doing here, right? You can create these data flows. You don't need Apache Beam. You can do it using Dataflow templates. So in the next lab that I'm not going to be demo for you now, you're going to use the Dataflow template. I will show you that though, even though I'm not running the lab. And the reason why I'm not running the lab is because there is another lab that I need to run for you this morning. Normally 3 labs is what we do in half a day session. And also because you need to do some waiting, people. When you run this lab, because Dataflow is spinning up a cluster, and it's not too long. It's going to take like 5 minutes or so to spin up the cluster, which is perfectly fine when you guys run this lab, but not for me to demo here waiting 5 minutes here, right? So anyway, I will show you how to use it. If you go here to your Google Cloud console, you go to Dataflow, and in Dataflow, you will find the option to run jobs. Anything you run on Dataflow is called a job, right? Create job from template. You see, create job from template. And here you're going to specify the name. And this is very important, right? The template itself. And you have here different types. You have a streaming. And normally templates for data pipelines are identified by the source and the sink, okay? BigQuery and normally the text. You see, Bigtable, change stream to BigQuery. Cloud storage to BigQuery. This is the one that you're going to be using in the lab, by the way. And then if you scroll down, you have all of these. And you see, this is not Google Cloud, people. Kafka, MQTT. This is another popular open source messaging system. MongoDB, another open source document database. You have multiple products that are supported here as well, right? Datadog, Elasticsearch, JDBC drivers, anything, right? And then if you scroll down, you're going to find batch as well, right? So you pick the template that going to BigQuery to Bigtable, for instance, and then it's going to show a set of parameters here, and you get to configure that, and it's going to run it. Once you specify the parameter, which is usually associated with the source and the destination, the sink, you can run it. Just click run, and it should run, okay? This is what you're going to be doing in the next lab. That, again, is going to take some time, but it's okay. Just waiting time, just a few minutes. So let me finish up this module telling you about Bigtable and data pipeline, because so far, remember, we assumed that everything we do the BigQuery. The sync part, we are landing data into BigQuery for downstream analysis. You're basically feeding a data warehouse, right? And naturally, the data warehouse, the default tool for building a data warehouse on Google Cloud is BigQuery, right? But there is not the only option. This is not the only option. The other option is Bigtable. So let me tell you a couple of things about Bigtable very briefly. Again, you're going to learn more about Bigtable in stage 2. So the first thing I need to tell you is this. Be careful, because the name of these two products, they look alike. Bigtable, BigQuery, BigQuery, Bigtable, they're similar, right? They're very different though, okay? Even though both are intended for analytics workflows, they are very, very different products, okay? So that's one thing that you need to consider. The other thing to consider is this. Bigtable is NoSQL, whereas BigQuery runs SQL, even though Google added like a year ago a new interface on top of Bigtable. So now you can technically run SQL queries, and there is a compiler or some kind of interpreter that will take the SQL statement and convert it to the special query for Bigtable. Bigtable is similar. The APIs are compatible with HBase. I don't know if you're familiar with HBase, another Hadoop, Apache Hadoop open source framework. Actually, they're both started. Google created this technology back in the early 2000s with MapReduce and Hadoop. All of these things started. They made it open source as HBase, and then in 2008, Google launched Google Cloud Platform, and they brought this into technology inside the Google Cloud, and they branded Bigtable, and since then has been evolving independently from each other. But the APIs, if you have queries for data in HBase, they're fully compatible with Bigtable. And the other thing I need to tell you is very simple and straightforward, and this is relevant for the exam. I mean, in the exam, when you have a question that asks you to select whether you want to use BigQuery or Bigtable, right? And the factor to consider here is very simple. If two things to consider. First, large data sets. Bigtable, for me, is the only product I know of that you see big in the name, Bigtable, and it actually means it. If you don't have big data, you can look at the documentation, but they recommend, there are different numbers there, but they recommend at least a few terabytes of data. If you don't have that much data, don't even look at Bigtable. Not only it's going to be expensive, but probably not suitable. You're going to have better tools. For sure, you're going to have better tools, and it's not going to be very performant either, right? Because it's specifically designed in terms of provisioning infrastructure and running internal processes for big data. So the first thing you need to consider is lots of data, right? At least a few terabytes, all the way up to petabytes. If you have several petabytes of data, that's perfectly fine. Actually, let's say the more data, the better sometimes for Bigtable. That's one thing. The other thing is BigQuery is different. In BigQuery, if you have petabyte of data, you have tables with billions of records, BigQuery would run that. BigQuery can handle that much data. But if you have a table with 200 records, BigQuery can handle that as well. There's no difference basically, and no significant impact on performance either, right? Or cost for that matter. Not Bigtable. Again, Bigtable actually requires large data set, big data actually, right? That's one thing. The other thing is performance. And this is very simple and straightforward. If you have a requirement from the business that says that you need to query this large data set that you load in Bigtable, and you need the query results, the latency of the query, you need to produce results in less than 1 second, what we call sub-second queries. You need the results produced within milliseconds. Then use Bigtable. Otherwise, no, use something else. As simple as that. That's it. That's all you need to know. If you have a business requirement that tells you we need to scan this Bigtable with billions of records, and we need to produce the results. Clearly, you see here application, time series, data, IoT, everything that is real time, right? Financial data, you know, these companies trading in the stock market, that you know that the few seconds of difference between buying and selling a stock that may represent millions of dollars or euros for certain companies. Those are the scenarios where Bigtable excels, right? Because it's very good at querying data. And if you do it properly, you see some references here using a row key, columns, and column families. Again, you're going to learn more about the schema of the data. This is super important, how you define the row key properly in order to get that. But yes, Bigtable is basically the only product on Google Cloud that could, if you do it properly, again, because you need to specify the schema the right way, query results, even if you were scanning billions of records within milliseconds. Again, as I said, otherwise, probably BigQuery is going to be better in every single metric that you want to use to measure the performance. BigQuery is very fast as well. You can scan a table in BigQuery as you properly use partitioning and clustering and all of those mechanisms available in BigQuery. You can get very good performance, very good latency with scanning billions of records, but never milliseconds. BigQuery is not capable of giving us milliseconds of latency from some queries. You can run a query within seconds. Maybe it's huge amount of data, may take a few minutes to produce query result. But again, you are not going to get milliseconds of latency on BigQuery with that much data. Bigtable does, and again, that is the key requirement, and the exam is very simple and straightforward. If the question doesn't say explicitly that we are building a real-time pipeline and some reference to the amount of data, Bigtable could be the option. Otherwise, no. Whatever other option you have in the multiple choice is probably another one. As usual, people, at the end of these modules, you have this table that is comparing the different products that we discussed here: Data Prep, Data Fusion, Apache Spark, and Dataflow, and the different applications, right? Applications, integrations, open source, velocity, or whether it's serverless or fully managed, right? So again, there is no recipe here. Just follow the business requirements, analyze the business requirements, constraints, budget, performance, availability, and with that on the table, you can run these resources and pick the right choice, right? There is a lab here that I'm not running for you. Create the data flow job from a template, stream data via data flow pipeline into BigQuery. Again, this is the process that's going to take a few minutes. Monitor data flow pipeline in BigQuery. You will see data, analyze results in BigQuery, and visualize. It's going to open Data Studio as well. It's going to open Data Studio. I'm going to ask you to build some dashboards there. I want to show you the lab. I'm not running it. I'm not demoing the lab, but I'm going to show you the lab to you. So this is the lab. So let's let's do a quick walk over the instructions here. These are the objectives that we just saw, of course. So create the BigQuery data set. You know how to do that. Be careful here because it's giving you two options to create the data set and table. Option 1 and option 2. Pick one, okay? You're going to be doing the same thing. So do either the Cloud Shell here running BQ commands, or do it directly on the console, BigQuery console UI, and do it there. But pick one because it's exactly the same. You're doing the same thing. So option 1 or option 2, specify the schema of the table. Copy required lab artifacts. Is downloading data. As usual, we have some Apache Beam job written in Java, JavaScript in this case. And again, as we discussed earlier with the Spark, we are not responsible for the code itself, the transformations itself, the job, right? We are responsible for data flow, for running it, right? So we run, this is CSV, it's using taxi rides data, collecting data from taxis from New York City, I think we're using New York again, real-time data. Create job template, this is us, create, I'm sorry, let me show you here. Create a new streaming pipeline, create job from template. This is what I showed you before in my environment, right? We're gonna use cloud storage text to BigQuery. You will specify all of these parameters. These are all the parameters as I show you. Remember when I show you this, right? In this case, in this lab, you're going to select streaming, go up here to process data continuously streaming, and you need to use cloud storage to BigQuery stream. And what you see in the lab instructions is how to populate all of these parameters that you see here. And at the end, once you complete, you don't need to complete all of them, of course. The lab will tell you which one. You have a lot of parameters here. For instance, specifying a type of machine. You're going to be using E2 here to run the lab, okay? And then again, at the end, you're going to have run job. And this is the process that you're going to need to do a little waiting, people. When you get to that point, you will see that you're going to need to do a little waiting. Here it's going to tell you. It will take 3 to 5 minutes for data to begin moving into BigQuery. If you have an error, if you run the job an error, please double check the previous step. But here it's going to tell you, run it again. Recreate the new job, because just it's a matter of waiting. Again, you need to wait for certain permissions to get properly propagated or things like that, right? But again, if you get an error here, I would recommend waiting like a minute or so and rerun it. And it should work. I ran this, I tested this, and it works. And then we're going to be looking at the data in BigQuery, and then some analysis here. And then the last part, you need to stop. This is very important. You need to stop the job. This is a streaming job. Remember that a streaming data pipeline ingests data continuously. We are dealing with an infinite data set that is continuously ingesting data. So for as long as the data pipeline is up and running, we'll keep ingesting data. So in this case, you need to go and stop the job. This doesn't happen with batch. If you were building a batch data pipeline in data flow, the data flow job will start, process all the data in the batch, and once the final last element is processed, the job will finish. That's another key difference between streaming versus batch jobs. And then create a dashboard. So in this case, you're going to go to Data Studio, and feel free here, people. You see, you notice that this lab doesn't have check my progress. Another reason why I don't want to demo this lab. I mean, I want to use the time to demo another lab in this limited time frame that we have here. But if you notice this lab, and then you complete, feel free to experiment. If you want to use build a different chart here, feel free to do it. Okay, this is you literally playing around with Data Studio and some visualization options, different chart types and things like that. But you will notice that this lab, you see, doesn't have a check my progress. So you can complete the lab. Once you end the lab, it's going to record that you completed the lab, okay? So you don't need to check your progress here. Okay? So, final module, people. Let me wrap this up. We're going to be talking about automation techniques. This is another short. This is the shortest of the module here, but this is our final module here. And then I will demo our final lab, and then I will enable the lab. Please remember that the labs are disabled and will remain disabled, these 4 labs here, until the end of the session, right? This is the one I just walk you through the instructions, creating a streaming data. And there is one more, use Cloud Run functions to load data in BigQuery, okay? This is the lab that I will demo and to finish up this session, okay? Let me remind you that you're going to have to complete, you're going to have until June the 22nd to complete 5 of these labs. Okay, and I will enable them now in a few minutes. I will be enabling this lab. Let me tell you about automation techniques. This is our final module, patterns and options for pipeline. We have a pipeline. So what we did already, whether it's EL or migration or EL or ELT or ETL, doesn't matter. We have a pipeline up and running, or up at least, ready to go, basically. Now we need to decide how we want to run it. And one option, of course, is always manual. I can go and call. You saw me here showing how to run these pipelines with Apache Spark or with Dataflow, run job, or you can do it programmatically using a scheduling mechanism. Could be time-based or could be event-driven execution, right? Depending on when something happens. And those are the options that we are briefly overviewing here, right? Automation patterns, cloud scheduler, and workflows. That's one way. These are two different products, okay? All of these are products in Google Cloud. Cloud scheduler, workflows, Apache Airflow, formerly known as Cloud Composer, and Cloud Run Functions. Event Arc is not a product. Event Arc is kind of a protocol that standardizes the way that events are reported. This is very relevant when we talk about processing data in event-driven approach, which is what you see here at the bottom, right? So scheduled, time-based, you have a scheduling mechanism, checking time and triggering a process. You see the example with Dataform, for instance. What happens downstream, we don't care, basically, right? It could be any kind of workflow or pipeline that we've been working with in this session, right? And the other one is event-driven. The typical example, the two typical examples, there are multiple ways to handle Event Arc. This mechanism that we're going to be discussing later is one of them. But the most typical use cases here is either cloud storage. One typical event is you upload a file in a cloud storage bucket. That could be an event and trigger a process to ingest the data and do something. Or pops up. You are subscribed, your pipeline, like in Dataflow, is a subscriber to a given topic. So when a publisher sends a message to that topic, that's an event, the subscription will send the message to the subscriber, and that will trigger the process, right? Those are the typical examples for event-driven pipelines. Multiple services. There are multiple ways to handle scheduling here. Cloud Scheduler, Managed Airflow, Cloud Run Function, Event Arc are some of them, right? Workflow is another one that is mentioned, but it's not. Workflow, the name is a little bit confusing because there is a product. In Google Cloud, there is a product that is called Workflow. I can go here and show you that this is actually a product that is called Workflows, right? We're not mentioning here, but it's another way that you can, another product that is available for you to orchestrate this workflow, right? You can create, again, I'm not going to do it this, but you can create, and I just wanted to show you that there is an actual product in Google Cloud called Workflows that you can use to do what we are trying to do here, right? So Cloud Scheduler is very simple, people. It's a managed service to run cron jobs. And if you are familiar with Linux, you have any kind of experience running Linux process or Unix processes, you are familiar with cron jobs. If you Google cron guru, you will be familiar with this. This is a very popular website that you can use to learn. It's called crontab guru. If you Google it just by yourself in your browser, you will see, and this is the typical configuration, right? You have these 5 segments, 1, 2, 3, 4, 5. The first refers to minutes, the second to the hour, the third to the day, the month, and the weekday, right? And you put the values here, and it's going to tell you how often you need to run something, right? This is a scheduling mechanism, right? Very popular to book and to program Linux jobs, right? Well, Cloud Scheduler is that. Cloud Scheduler is a service that you specify your cron jobs, and they will follow this specification to execute them, right? You can specify different things downstream, an HTTP call. If you have some kind of web traffic, you can handle that there, of course. PubSub, workflows. This is workflow. This is what I just showed you. This is workflow, the actual product that handles HTTP traffic. This is essentially web traffic when you have APIs communicating via that protocol, right? The HTTP protocol. Get, post, put, those commands. This is how you trigger a data form SQL. You have a data form. Remember, data form SQL is what we created in the fourth module, the first module that we covered today, and then you trigger it. As I mentioned before, you can go to BigQuery data form and manually schedule that workflow to run as often as you need to run it, okay? However, the problem is you don't need to do it data form job by job or any workflow by workflow, right? Which is kind of a nightmare for maintenance when you have multiple ones to maintain, right? So this way you centralize. You have this platform that would allow you to centralize. Somebody would be responsible for operating these services, and you have one single point of entry where they can administer all of these jobs. That's why I say I don't care what we run downstream. We are focusing on a scheduling mechanism that would centralize the administration of those services, right? Collecting telemetry, logging, monitoring, looking for errors. If one of the jobs fails, it's going to generate an alert and you want to trigger something to check what's going on. Those things can be managed using these services, right? Manage Airflow, again, used to be called Cloud Composer. Mentioning this because if you study, go to training material on Manage Airflow, you will still see, I'm pretty sure they're going to find a lot of references to Cloud Composer still, because it's just the new branding was introduced by Google a few weeks ago, right? So it's basically, you may know Apache Airflow is a framework built or programming model as Apache Beam using Python. This is pure Python language, people, and you can build this. The only thing I want to say about Manage Airflow is this: make sure that you actually need it, okay? Because it's expensive and it's not that simple to administer, which is a great tool. Apache Airflow is very powerful, but make sure that you need it. And how do you determine if you need Apache Airflow? Look at the complexity of your workflow, right? The dependency mapping that we mentioned before, right? What needs to happen for certain processes to be executed? If you tell me, run task A and then task B, I would say, you don't need Apache Airflow to do that, right? Run one and then run the other one. But if you tell me, run A, B, and C, wait for C to finish and look at the results. If workflow C shows 1, do this. If shows 2, do this other thing. And then wait for flow A to finish, take the results, ingest the result. If you describe your environment, what you're trying to build here, and it takes that much time describing all the dependencies, then it's a good sign that you may need Apache Airflow, right? And again, if you tell me do A and then B and then C, that's it. You can do that, schedule that one after the other, and that's okay. But we are working with heavy dependencies, especially checking results, and depending on the value, apply some conditional filters or routing the process to different workflows downstream, then Apache Airflow. Use it, very powerful, very useful, as long as you actually need it, right? Otherwise it's overkill. Again, it's not cheap, and it's quite complicated, by the way, to deploy and to manage. Python using Apache Airflow, we mentioned already the fact that it's Python. You need operators, okay? It's not like a Python that you can do whatever you want, like a Python generic programming language. There must be an operator. If you want to integrate in your workflow in Apache Airflow, I don't know, BigQuery, must be an operator available within the Apache Airflow framework that supports BigQuery, which it does, of course, because it's all of these cloud providers. And the other important thing about Apache Airflow, of course, is the fact that it's open source, community maintained, and there is no direct affiliation with Google Cloud or any other cloud provider for that matter. So you can easily integrate these complex workflows that we mentioned before, multi-cloud or hybrid architectures, running stuff on premises or another cloud providers, can be easily handled by a platform like Apache Airflow because it does support operator for all of those providers, right? This is an example of running a code. Here you see the DAG. The key component, by far, the key component of Apache Airflow is the DAG. The DAG, we saw DAG already in the previous module when we talk about data fusion, for instance, or any kind of pipeline. It's directed acyclic graph, okay? So So it basically set these dependencies, these dependency mappings that we mentioned before, right? And you see an example here using, look at the functions here. Dataproc, you see Dataproc, still using Dataproc. Create the batch operator. Cloud storage to BigQuery operator. What is BigQuery insert job operator? It's all about using these operators, okay? Everything you want to do in your flow, in your DAG, must be an operator supporting that, especially the product that we are trying to use, right? Then you have Cloud Run functions. Used to be called Cloud Run. The second generation of Cloud Run, Google used Cloud Run. Cloud Run is a serverless compute resource in Google Cloud to run containerized applications. If you have containers, you are building applications, software services using Docker containers, and you need to run it in Google Cloud. You have multiple options, but one of them is Cloud Run. Cloud Run functions, this is not about Cloud Run. This is about Cloud Run functions, which is basically running a function, a code, a script, a coded script based on events. Based on events. When something happens and you see the list of events here, an HTTP call, like an API, a PubSub, again, when you subscribe a service to a specific topic, cloud storage, when you upload a file, when you move a file, when you delete a file, those are all events supported by Cloud Run functions as triggers, and you want to execute whatever you put in the code. This is coding. Essentially, Cloud Run functions, it's important to note that it's a coding programming mechanism to do something with an event is detected. If you're familiar, we have anybody here coming from, I don't know, AWS, for instance, Amazon Web Services is like the Lambda functions that you see in AWS, right? Very similar functionality, basically. Completely serverless and supports multiple programming languages. The fact that it's based on Cloud Run, I just mentioned that it's based on containerizing the service, that means that you can use any multiple programming language. As long as you have a package that can be containerized in a valid container image, you can run it. Cloud Run will run it, right? So naturally, multiple programming languages supported. And it's all about programming triggers. The key thing about Cloud Run functions is that you are building a trigger that will detect an event and do something downstream. Normally, another important thing about Cloud Run functions is that they are intended for lightweight workflows. Actually, there is a deadline. The first generation of Cloud Run, it went like 9 minutes, and then it will time out. The second generation, based on Cloud Run, I think the timeout is about an hour or something like that. But still, it's intended for quick things, okay? There is an event, you get data, you pick the event, and you call a function downstream. That's it. The Cloud Run function finishes right there, okay? The idea is, again, remember that, excuse me, in this module, we are having a conversation about automation, right? So that's the idea of using Cloud Run function. Automate the process of detecting an event, a message coming via PubSub or file uploaded in a bucket in cloud storage, and call a downstream function. That downstream function may be a pipeline in Dataflow or Apache Spark doing some data transformation, right? That's not done by the Cloud Run function. The only job of the Cloud Run function is to detect the event and call the backend service. That's it. May do some checking, some validation. Why not? As long as it's quick, because again, it's particularly intended for lightweight workflows. You can do that using Cloud Run functions. I'm going to be demoing this in the next lab. And then you have Event Arc. This is great, this mechanism to detect events, but we have a problem. HTTP, PubSub, cloud storage, Firestore are very different. The schema, the data that's coming, the schema, the specification of the event itself with the data that we need to process is very different depending on the source. That's a problem. And Google introduced this protocol, Event Arc, that you see right here. That is what we are talking about now, right? This Event Arc is, where is it? Hold on. Why am I here? Hold on, I have the wrong visualization. Just sorry, 1 second. So Event Arc is a unified event-driven architecture for coupled services. I just read the specification, but essentially is regardless the data source, the way that they report on events is consistent. We want to achieve certain level of consistency in the format of all the messages that the events that we need to process, right? Regardless resource, Google Cloud, third party, this is particularly useful when you are collecting events or reacting to events generated by external sources outside Google Cloud. So you can use Event Arc as a way to as a way of using the same protocol, right? So your downstream, whoever receives the event, they know how to process the schema of the data reported by the event is consistent, right? That's the idea. That's it. That's what it does. There is a unified cloud event message. You can Google cloud event and you will find the actual specification, right? The specification is a JSON file that specifies the format, right? Which is, of course, very useful. So, for instance, one example, you are inserting records in a table in BigQuery. Fine, you can do that, but you need to do something downstream. When a new record is inserted on a table, you want to trigger, you want to create an Event Arc instance, and somehow downstream, another service will pick that up and do something. You need to check, I don't know, whatever. Again, we don't care about the downstream functionality, right? We are concerning here in this part of the session on automating this process, right? You can automatically do something when, in this case, an insert is processed on a given table in BigQuery, right? And you can use, again, Event Arc, and you see an example here how to do that, right? Using this standard format. You need to report on insert in a Spanner or AlloyDB, you could do the same mechanism, right? Very useful for, again, consistency and robustness for those downstream services. They don't have to handle multiple formats, for instance, right? And as usual, people, to finish up here, we have this table comparing the different options that we just mentioned: trigger type, serverless, coding effort, and programming languages supported, right? So let me demo this final lab, and after that, I will be enabling the 4 labs that we are introducing today, and that's it, all yours, guys. So I'm gonna let you go and start working on the labs, and we're gonna review the requirements again, just in case, for you to qualify for stage 2. That notification, remember, will come via email from Google by the 24th of June. That is what, next week, like Wednesday next week or something like that, right? But you need to wait for that email, not before June the 24th. Even if you complete these 5 labs today, do not expect the follow-up from Google today, okay? Google will be sending out those notifications regarding next steps by June the 24th. Okay, let me get the lab here. I'm going to open our final lab. As we did before, I still have the previous. Please, people, please let me insist on the fact that you need to make sure before you start the lab, make sure that you close all the previous lab. Do not run more than one lab at the time, okay? That's what I'm checking now, that I don't have any other previous labs running. So this is the lab. Use Cloud Run functions to load BigQuery. We create a Cloud Run function. We deploy and test the Cloud Run function and view data in BigQuery. That's the best way to check that is working, right? If you are populating data in BigQuery. So I'm going to go ahead and start the lab. I'm going to wait for my credentials here. I'm going to open in an incognito window. We know the drill, of course. As I usually do, I'm going to open a couple of tabs. I'm going to duplicate my tabs because I'm going to be checking the Cloud Run. I'm going to be Cloud Run functions. I'm going to be checking on BigQuery to see if we get populated with a table with data. So I'm going to keep couple of tabs here, which is something, as I said, you don't have to do it, but if it is useful. Okay, So let's go ahead and follow the instructions. Probably going to use Cloud Shell. So I'm going to go ahead and open Cloud Shell. I'm going to go back to the lab instructions here and check first steps here. So let's see, login. The first part, of course, is always the same. Cloud Shell. You can skip all of this. Enable the API. So let's start doing this step. We're going to enable the APIs. We are using all of these APIs here. Most of them, you don't need to enable them. This is just in case thing. Enable them all. Cloud Functions, Artifact Registry. These are the things that we need to use. Cloud, remember, Cloud Run functions now run on top of Cloud Run. Cloud Run containerizes everything. Every code that we run is being containerized by Cloud Run. If you create container images, you're going to need Artifact Registry, right? That's why you see all of these services being enabled here. We're going to set some permissions because, as usual, when you have multiple services talking to each other, you're going to need to make sure that they have the proper permissions to do that. And then we're going to create the function using JavaScript, in this case, one of the valid languages. This is the code. Again, the function itself, the code, don't worry, it's all given here. You can check the content here. But remember, this is loading data into BigQuery using this Avro file. I think it's using the Avro file that we saw in the previous lab, I think. And here we create that, and then we're going to deploy. One is to create the function, another thing is to deploy it, right? Running the function. And once it's running, it's basically waiting for the event to happen, okay? And then we're going to check that the data was loaded in BigQuery. That's what we are doing here. So let's go ahead and do it. Let me go back to task 1 here. Let me switch. Opening Cloud Shell. Okay, I have Cloud Shell here. Let's get the environment variable with the project ID. Always need a project ID somewhere. Region. So the region, remember, follow the instructions to the letter, okay, to the letter. We're gonna set these configurations in Cloud Shell, the region, what else? The platform, and event arc, Cloud Run and event arc. You see we are assigning here, configuring event arc and Cloud Run. Enable the APIs. Again, probably they are already enabled, but it wouldn't hurt just to try to enable all of these services here, right? There is a warning here, people. There is a warning, and hopefully I should be able to show you this. For event arc, it takes longer. So it's going to take me a couple of minutes here. So by the time I check, the event arc may not be available. So here is a warning telling you it may take a few minutes before all the permissions are propagated. So if you have a permissions error, just wait like a minute or so and try again. Right? Eventually, it should work. You have a proper warning here regarding that. So I'm going to continue here with the steps. I'm going to set the permissions I would just mention, right? So I'm going to run these commands. Let me make this a bit larger as I did before. So make this larger so you have better visibility of what we are running here. Run that, we assign the permissions. Retrieve cloud storage service session for your project and granting permission to publish message to PubSub. So when we load file in cloud storage, it will trigger an event by publishing that message in a PubSub topic. So you need, again, permissions to do that and just assign that. Let's create the function. So now what we're going to do is to use an editor here. Let me clear this up. I'm going to use Nano. And again, just simply people copy and paste the code. You can browse the code. If you don't understand something on JavaScript, you can ask Gemini. Just paste this in Gemini and ask Gemini to explain. It's going to do a great job explaining what the code does. This is, again, mirroring what is going to happen in real life, because usually for the data engineer, somebody will share this code and our job will be to execute it, right? Or check it or execute it or test it or something like that. So let's create a cloud storage bucket here. Let's create a cloud storage bucket. Again, using the project ID, you see, as usual. It's a good way to make sure that we don't have duplicated errors. Create a cloud data set in BigQuery, load Avro. And now we're going to deploy the function. So let's install 2 JavaScript libraries in order to deploy the function. We're going to be using JavaScript, so we need to install a couple of libraries in JS. So just run this line, install cloud storage and BigQuery. Again, JavaScript will need to connect with cloud storage and BigQuery, and therefore we need to install the libraries, the custom libraries to do that, right? It's installed, that's it. And then run the following to deploy the function. And here is when you may have an error, okay? So let me clear this. I'm gonna paste. This is Cloud Functions Deploy. You see G Cloud Functions Deploy. You have second generation and you have all of these specifications. You will recognize some of the parameters that are very similar to the data flow, like the service account and the working directories and all of that. So it's going to take a few seconds here. If it fails, see, it's failing. Good. I wanted to see this, so I'm going to show you. And very clearly, it should tell you you have permission storage. Permission storage buckets denied. Okay, that's fine. This is what the lab is basically warning us here. And I can show you again. If you see an error message relating to event arc service agent propagation, wait a few minutes and try the command again. Okay, that's it. There is nothing for us to do here other than wait and try again after a while. So let me clear this. This is wrong. Clear again, and let me copy the whole thing. I'm gonna keep trying until it works. Eventually, it should work. So let's wait here. Much better now, people. You see, it looks like it's working. You can check. You can check. As we leave this working, I can switch to another tab in my incognito window here. And I'm going to go to Cloud Run Functions. So if you go to Cloud Run Functions and everything works as expected, you should see here in services, we should find a function. It's not there yet, it's processing. You see here the information, the languages. You can actually create a function if you want to do it. I go to services. You can go ahead and, I'm not going to do it. We don't have to do that, but you can write a function from here. You don't need to use the command line interface. You can create function from here. Let me go back and check. That is telling me that it's still creating the Cloud Run service, right? You see, creating event arc trigger. We are waiting here. It's creating all of these resources. And there you go, right? When you go back here and you refresh, eventually you're going to start seeing this is the function that we are running here that at the moment didn't process anything. If you want to keep checking, again, I'm waiting here so I can go to event arc. If you want to go to event arc and see if something is happening here, you can go and check again. As you wait, you can use the tab and there you go, right? You have this event arc instance, the trigger that we are creating here, and it's associated with the load BigQuery from Avro. This is the name of the function. If you remember, when we look at the Cloud Run function here, where is the Cloud Run function? Cloud Run, this is the name of the Cloud Run function, right? When I go here, is done. Is done, completed the process. Again, I can double check. I can go here and see the green check here, double checking that is okay, but nothing happens. You see nothing because we didn't generate any events. The next step for us will be to go to cloud storage and upload the file. The event, again, is a new file uploaded in a bucket. So if I go to cloud storage here, I will see a bucket, which is this one. And these are other buckets generated automatically by the service. As I mentioned before, these are simply other products on Google Cloud using cloud storage internal, right? But the bucket that we created is this one here that is, for the moment, empty, right? So no events, the cloud function didn't run. So next step here in the lab instruction is to, let's check. Here is asking me to check. And then we're going to do this. Run the following command to download the Avro file and then upload the Avro file to cloud storage. This step 5 that you see here should be the one that will trigger the Cloud Run function and get the data in BigQuery. So let's see if that actually happens. So let me check first. The lab is asking me to check for the event arc. We saw that already in the console, but you can run and you can see that it's active already. This is the event arc specification. And then, as we said, let's download an Avro file. Here, I'm going to run this and get an Avro file downloaded here, these campaigns that we used before. And the next step is to upload that file into cloud storage, right? This is gcloud storage copy. We'll upload the file to cloud storage, right? And that's it. Now what I can do here, two things. First, I can go here. Sorry, guys, I wasn't showing you the right thing, but it's basically I just run. Let me do that again. I didn't do anything here other than copy. I just run these gcloud storage copy campaigns into the bucket, okay? And as I said, I can go here and refresh and confirm by refreshing that we have a file. You should see the campaigns Avro uploaded here. That must be the trigger that executed the event that executed the Cloud Run function, okay? So how can we check that? Well, there are different ways. One way is to go here. Let me stay here. Let's go ahead and check Cloud Run functions. Cloud Run function here, I can see here in services, the Cloud Run function, and I can look at login. It's going to show me login here, the logs. Showing this, you can check here, it's loading. The login data. Of course, you have errors, you have service level objective, and this is the data, right? This is showing me that the Cloud Run function executed. And you can check here. Of course, you can open here, look at the payload, and you can find the data, okay? Create table campaigns. I can see here that the table was created. Looks like it's kind of still running here, apparently, right? This is one way that you can check. And the other way, of course, the most straightforward way is to go to BigQuery. You can go to BigQuery. Go to BigQuery and check that you have data, right? You can go here to Cloud Shell, back to Cloud Shell. Let me make this larger here. You can go to Cloud Shell and, no, that's not what I wanted to do, sorry. Clear this, run a BigQuery query with BQ command, and you should see data here That's the data that got populated. In case you want to double check, just go to BigQuery to the console. And again, obviously you should see the data set, the table campaigns with the data loaded, right? This is how you automate the process of detecting an event, in this case, uploading a file to a cloud storage bucket. Of course, the specification of the function refers to which bucket you are listening to, and then triggering the event when you upload. There are different events, okay? You can trigger an event when you insert, load a file. When you delete a file is another event that you can catch and do something, or move or rename. There are some metadata changes on the file that are also valid events that you can process downstream via Cloud Run functions, okay? So that's it, guys. When you complete that, as we do here for every lab, go to score, make sure that you check your progress, make sure that you get your 100% here, like 100 out of 100 here, and that's fine. That means that everything is fine. I can go up here and end the lab, okay? And that's it, people. With that, we are finishing up the session here. What I'm going to do now is to briefly review. Let me open this. Let's review the requirements. Remember, people, that this is a stage 1. Stage 2 is starting next week, or the week after, actually, with the sessions. There are weekly sessions, hour and a half, kind of exam guide review sessions, office hours kind of style. In order for you to be compliant and to qualify for stage 2, remember, you need to complete any of the out of the 7 labs that we have here, at any 5 of them, anyone, okay? Do not expect the list of which labs you need to do. Any of them are okay, and complete at least 5, and Google will reach out. Again, look at your inbox. Doesn't matter when you complete these 5 labs, Google will reach out to you, will send you a notification on June the 24th. You see, that's very clearly here, June the 24th, okay? You have all the labs that are there disabled. You have these labs, the 4 labs that you have at the bottom, they are still disabled. If you refresh that page in your browser, you will see that now all the labs are enabled, okay? I just enabled all the labs. There you go. All the labs are now enabled for you to work on them. You have until 11 p.m. India time from June the 22nd to complete this lab, 5 of them at least, okay? And remember that these sessions, these YouTube sessions, yesterday's and today's, will be available for 7 days. If you miss part of the presentation or you didn't attend one of them, you can use the link in the meeting invite and still watch this presentation for 7 days, okay? That's it, guys. That's all I have for you. If you have any problems or any issues, you know the drill. Look at the email. In the email from Google, you will find links to online forms. Depending on the problem, you may have a question about the program. You may have problems with this platform, this quick lab, this Google skills, in which case the instructions will tell you how to reach out to the support, because only these people should be able to help you if you have your account blocked, for instance, or something like that. And again, hopefully you will be qualifying for stage 2. May or may not see again. I'm not sure yet if I'm going to be participating on the stage 2, but hopefully this was useful. I wish you very good luck. Hopefully within a few weeks, I will count you as colleagues, as professional data engineers in Google Cloud. And that's it, guys. That's all I have for you. Go ahead, all yours. The labs are enabled. Don't forget the lecture notes. The lecture notes contain the PDF file for all the modules that we cover here, the slide X that we presented here. All of them are available there, okay? That's it, guys, for me. Thank you very much. Have a good rest of your day. Good luck. See you next time.